And I'll get into the actual analysis here in a second. I'm still trying to log into the chat tool so I can see if anyone is chatting me on those streams. Click all the squares with a vehicle. That's lit. Don't you just love these little prove I'm a human things? Are you on Android or iPhone? This is that iPhone, yo. Standing desks are lit. If my office was better organized, I would have one. I previously had one. I'm a big fan of... I don't like standing like all the time, like making me stand. I like being able to switch between sitting and standing. And I think that's a really helpful thing. And also research says so. So, yeah. All right, we're rolling. So we are now on all streams. So here's a playlist. So this is part 10 in this playlist, where I have been from start to finish, 0 to 60. How do you get data for a research paper? How do you analyze that data? And I'm using Python. And then how do you actually make a like publishable paper out of that? So today we are on this analysis 7 file. So previously we ran leave one out cross validation without interactions using an elastic net, with interactions using an elastic net. Okay. Sequential feature selection using generic univariate select, and then also using vector regression. And so we had already done that, and we'd collected all these variables, and we were getting ready to create analysis 7. And then I realized a problem. And the problem was that I was not numerizing my, which one was it? My rule breaker columns. So that seems like this like minor thing about one little variable, right? But if you understand how included and omitted variable bias work, the fact that I was not numerizing this variable potentially contaminated all the independent variable measures. It would not have pertained to the generic univariate select. This is actually a really great reason why it's important to use multiple analytical methods, because the different analytical methods have different requirements and different assumptions, and they present failure risk along different lines. So the fact that I had this unexpected failure that would have contaminated collinear independent variables in a regression, in a multiple regression, but that would not have pertained to a generic univariate select, which is not a multiple regression. So this is like a reason that having robust results is a really big deal, because I could argue if my back was against the wall, thank God it's not, but if my back was against the wall, I could argue, hey, these features down here, okay, let's drop all the ones, but the twos are being significant in both the generic univariate selection criteria and the multiple vector regression criteria. And so for that reason, even if we assume that there is included variable bias, there is omitted variable bias, at least these ones are still pretty safe, right? So you can argue things like that if you have to. But the better thing to do, and this is the path that I took offline, the better thing to do is quite painful, and that is rerun all of your analysis. So between streams, and this is just giving you the background before we pick back up, but between streams, I realized rule breaker columns were not numerized, and so now I have numerized them, and I reran the elastic net cross validation with and without interaction effects, and it did modify some of the outcomes. So first of all, one of the things that it did is it reduced the number of variables before filtering, to the point that this 165 is actually not correct. It's 143 now. So I'm going to delete this, because the rule breaker effects, there are 3 of them, and they are rated on a scale of 1 to 10. there are not samples at every value. So like 2, I don't think was selected, right? So you might think 3 by 10, so there's 30 factors. It was actually closer to 20. So we went from 165 to 143, so we lost 22. We lost 22. And really, we lost 25 and gained 3 is how that worked. So that means there will have been 5 in the possibility of 30 that were never selected. And so to give you an understanding of why numerizing is important, basically we were previously treating the variable as categorical, but we want to treat the variable as continuous. Now, technically I could treat the variable as categorical. It's not going to necessarily produce wrong results. Even when we talk about included and omitted variable biases, you could argue including the categorical form still does not fall victim to those because the variable is present, it's just in a different representation. So there's different ways to argue these and like defend yourself against possible critiques. But I can tell you that my intent, as spelled out in the paper and the methodology and just the general way the current paper and the previous papers that I'm building on, the methodology that we generally follow, is that the 10-point Likert type variable is treated as continuous. So technically it's a Likert type variable. And if you go, it's like on a, here, Likert type question, they can be treated as categorical. And you'll see, so mine is, this is a 10 point, so there's 10 options, scale of 1 to 10. But sometimes you'll see, you could see a yes or no, which is a Likert type, which could be treated as a Boolean or a categorical. You could see a 3 point, a 4 point, a 5 point, a 7 point. And over the range of like 3 to 5, it's actually a best practice to treat it as categorical. So with 10, you kind of got to ask yourself, like, why? Like, what's the purpose there? Why? It could lead to overfitting because you have a large number of variables. So that's a danger there, is that you could be overfitting. The other point is just like, why are you even doing a 10-point scale? And the answer is, if you want to treat it as a categorical variable, because you don't want these discontinuous effects, you want a continuous effect. So that's kind of the whole purpose of using a 10-point Likert type variable. Thanks for the follow. Thank you for the likes. I appreciate that. I'm seeing something junior crew person. I don't actually know what that's referring to. Y'all can also check out Twitch or YouTube if you want to get a better view of the screen, basically. I'm using a wide angle lens, but I know I still can't capture the whole screen. Okay, so I gave you all that background. Some of the numbers did change. None of the numbers really changed drastically. But for example, gender is now in the top 40% of factors. It was previously in the top 35% of factors. Okay, so there's some slight adjustments like that, but the overall, I'm glad to say the overall findings haven't changed much. I will say that the R-squared value on the R-squared value has gone up substantially, which is really good. And that shows that a continuous treatment of this variable, what does it show? So the way the elastic net works is it'll pick the top best variables. So basically, this shows that we have concentrated information into fewer variables because it's still picking a fixed number of the best, but that fixed number of the best is doing more explanatory work. So we've basically concentrated information into fewer variables, which is one of the main reasons that I wanted the continuous variable over the categorical form. Cool. All that background, what are we doing today? We have too many variables still. So if we look at this preferred one, you see this is the preferred one. And let me touch on two other things. I'll touch on why is this preferred, and I'll also touch on, hey, we realized that rule breakers was not numerized. How did we realize that? The answer is pretty straightforward. I was building this supermodel. Love that term, supermodel. Lewis Williams, what's up? Thanks for joining. I was building this model right here out of these surviving variables. So this elastic net will have some surviving variables that are identified as important features. This one over here will also have some surviving variables, and then this will have some surviving variables. And so literally just taking all three of those groups and dumping them into a single model, and that would be the supermodel, and they are called the important candidates. Then we're going to reduce that and find our truly preferred candidates after the collinearity is accounted for in a multiple regression. Okay, so when I was doing this, rule breakers wasn't an important effect. It was like rule breakers something. I don't know. I forget. We'll get there in a minute because it ended up surviving anyway. But when I did that, I realized that in my regression output, it was not showing up on a single line. It was showing up on like 8 lines. And that's when I realized, oh shit, it has split this into a categorical variable, which is not what I want. And so that is the point where I said, okay, let me literally go back to my first file, the data wrangler, and numerize it. So that's how I found out that it wasn't numerized, is I got to the final stage. Sometimes it'd be like that. It sucks, right? You do all your analysis, you get to the final stage, realize something's wrong, and you got 2 options. One is you can adjust your conclusion, you can adjust the way you're interpreting it, you can basically bite the bullet and accept the caveat. Or 2 is you can go all the way back to the start or wherever the problem was introduced and fix it. So I did the latter, which I think is more ideal, but it's certainly time consuming. But I had the time in this case. Okay, so that's how we figured out that it was not numerized. Why is this my preferred elastic net? Basically, I'm going off of 2 things. I'm going off of the count of variables, and I'm going off of the R squared. And what I want to do, so there's like a few ways that we can do this. One way is just look for the maximum R squared. You can see there are multiple models that round to the same R squared. In this case, I could pick the one that has fewer variables, and the rationale there would be the additional variables are providing no additional information. Which is equivalent, by the way, to an adjusted R squared selection. And it's not necessarily equivalent to an AIC or BIC selection. So AIC and BIC selection assumes holding constant the sample count. And even on cross-validated, people are not understanding this. So cross-validated is the Stack Overflow for statistics. It's a really great place. How to interpret it and increase to AIC and adjusted R squared? This is my question. No one gave an answer. There was several comments. There's some pretty informative comments, some smart people. This guy has like 50,000 upvotes or whatever. But they're still saying stuff that's wrong. like this thread says that there's no justification for adjusted R squared. I mean, I gave like 6 justifications for adjusted R squared, but I've neither been upvoted nor accepted. But the other answer has 0 upvotes. And that's after my upvoting it. So I think it's like, I think it has some downvotes and some upvotes. And then here is the top answer with 1 whole point. So it's like it's not a trusted answer and it hasn't been accepted. And the answer is, I don't know if it has any optimal properties, but it is surely taught in that context. I gotta ask, like, how is that a good answer? And this person has like 60,000 points on cross-validated Stack Exchange. So I think my answer is better than this. Like, I don't know if there are any justification. Well, let me give you 6. And maybe you could give me an upvote. Anyway. So model selection criteria, generally we prefer something like AIC or BIC or WIC. There's a bunch of them. These are the information criterion, and they have various proofs of different things in information theory. Adjusted R squared does not have a proof in information theory because it's not an information theoretic measure. It is a inferential statistical measure. And I gave 6 reasons that it's still a good selection criterion, particularly when you are doing non-predictive analysis, when you're doing inferential analysis, which does not need to be predictive. And that also relates to what this guy's saying, where he's like, stepwise is problematic. If you read the question, if you read why, really it's machine learning stepwise is problematic because it turns into a closed box. It's not theoretically guided. You don't know why the answers are what you said they are. And so there are valid criticisms of, and that's in a predictive case. P-values don't matter. Well, they do matter for inference. They just don't matter for prediction. So there's these like broad generalities like stepwise model selection is problematic. What you should say is some kinds of stepwise model selection are problematic, particularly under cases of predictive analysis. But I'm not doing predictive analysis. I'm doing inferential analysis. Hey, Caden, good morning. What's up? What's up? So anyway, long story short, I asked this question. No one's given a good answer. And it feels bad. But I think the reason no one has given a good answer is because the truth is R squared is pretty good. And the cool people don't want to say that R squared is pretty good. Adjusted R squared is good. They don't want to say adjusted R squared is good. They want to say the information criterion is good because they're like the fancier things. And there's this hilarious irony because the people who are like, oh, you have to use information criterion. And you're like, why? And they're like, I don't know. And then you're like, which information criterion? And they're like, well, AIC or BIC, of course. And you're like, well, which one in which case? And they're like, I don't know. And then you're like, hey, did you know that there are actually others like DIC and WIC? And they're like, no. And they're actually better in these other use cases. So really, when it comes down to justification, and this was one of my arguments, like at the end of the day, what do we even mean by justification? If we're talking about scholarly justification in the case of a journal publication, in the case of peer review, what we technically mean by justification is that my peer reviewer will approve it. That's what we technically mean. And so it's not technically the case that we need to find the ideal measure if such a thing exists, which by the way, it doesn't. Because we're always learning. At any point in time, you may think that you have an ideal measure, but there could be some researcher across the world experimenting with a better method. He just hasn't published it yet. And by the way, in 5 years, it will be very well known that that's like the best practice. So following best practices is not the same as following an ideal measure, right? So let's say that we do follow best practices. Okay, that's pretty good if it's well known. But if your best practice is a niche, if your best practices is in a niche, it might not be well known. And that's where one of the virtues of R squared and adjusted R squared comes in is it's not a niche measure. Like everyone knows what R squared is at the PhD level, basically. And frankly, if you don't know what R squared is at the PhD level, that's your problem. The vast, vast majority of people know what R squared is at the PhD level. And they may not know what these information criterion are. So even if you are some third party, you think the information criterion are really great, when it comes to me and my peer reviewer, I just need to convince them. And if they're aware of what I'm talking about, that's a really great component of convincing them, right? So adjusted R squared works. There's a lot of people who complain about it, but I think it works. If I look at two R squareds and then I pick the one with fewer variables, that's effectively judging by adjusted R squared because we're penalizing numerous variables. So there's a few ways that I could go about this. One is I could just say this is my preferred one because it has the highest R squared in the list, you see? The other approach that I can take, one other approach is I can go like R squared divided by the number of variables. Then I would end up like here, 0.5. I don't really want that because there is a loss and explanatory power of the model that's really big. There's a big loss and I don't like that. So we go from 0.66 to 0.5. So this is like, what's the fraction there? 10% would be 0.05, so 30%. So this model explains more than 30% more of the data than this model. Now imagine that you're a business owner and you're trying to make predictions about your customers, or you're trying to explain what your customers are doing. Do you want model 1 or do you want this other model that can explain more than 30% better? um, do I want a scholarship? I don't want a scholarship. Thanks. I'm probably done with school for life. Like, I'm really over it. Cosmic Zig, what up? What up? What am I working on is why are there so few women in programming? So I'm working on a research paper. It's called Coding Bootcamps and Gender Equity. And basically the idea is, hey, coding bootcamps are about 40% female. CS programs are about 20% female. Is there something that CS programs can learn from coding bootcamps? So what are the differences there? What can we learn? That's the point of this research paper. Where'd you get the data? This is my original data. I administer, so check this out. So here on YouTube is a playlist. And so the live stream that's ongoing is part 10 in this playlist. But if you go to parts like 1 through 3, I'm collecting the data. So the long story short is that I use Amazon Mechanical Turk for participant recruitment, and I use SurveyMonkey for survey administration. I also use something called OSF, Open Science Foundation, for hosting the informed consent document. Can you share the playlist? Yeah, the playlist is public. I'll send it to you though. I know I have your Discord, so I'll send it to you on Discord. Cool. So what was I saying? How do I select my favorite? How do I decide that this one is preferred? So there's a few approaches. One approach is that I just go by R squared. The problem here is that there are too many positive results. If I had a bigger sample, let me be honest, if I had a bigger sample, I would prefer this. The reason I don't prefer this is because there are 113 variables and I don't have 113 samples. So when your variables outnumber your samples, you run into problems with degrees of Friedman and you can't, degrees of freedom. Did I just say degrees of Friedman? Oh, geez. What was your sample size? So it's like about 100. Let me see. So I have 114. So technically I could go, 113, but I have 114. So technically I could run it. Here's the problem though. This is the elastic net without interaction variables. Here is my elastic net with interaction variables. And then these are a collection of sequential feature selections that are not using elastic net. And I get these variables. So I don't really just need to support 113. I would need to support 113 plus 48 plus, what is that, another 20. Was there different demographics? Absolutely. Absolutely. So yes. So I include a bunch of standard sociological controls. Let's open up the data set. You can check this out. This is all open source, y'all. The data is obviously, it's anonymized, but the data is also open. Where's my CSV file? Okay. So this is the wrangled file and the disqueued file, but here's the raw file. So this is literally downloaded from SurveyMonkey, and then I take out their IP address and their name and stuff, and this is the responses. So columns are variables and rows are samples. And so I have a ton of sociological controls, like which race ethnicity best describes you? What's your age? What's your household income? What's your gender? What state do you reside in? So tons of demographic controls. and really diverse respondents, right? So gender, female and male, but I also have two other responses. Um, the problem is two responses, you can't really do statistics with two responses. I mean, you technically can, but you're going to have like zero confidence in your results. So I end up dropping some of these, like such as other gender responses. So I start with 114 samples. That's row 115, but you also have the title line, right? So that's how you get the 114 samples total. But then you drop the two non-gender and do some skewing adjustment. And there's also some sus responses where they just put like 1 on everything. And so I end up with 106 sort of credible responses. And you can see that this includes partial responses. So that this person, ID number 102, gave some information, but there's a bunch of missing fields. So depending on which variables land in my regression, I may or may not be able to use that sample. And so some regressions have sample size as low as like high 80s.
Daddy, we got a packet for you.
Awesome.
I got a sticker.
You got a sticker? That's really cool.
And it's red.
Good job, dude.
You want it now or later?
Later.
So, the mommy's gonna get the packet to you.
That's cool. I'm doing a video right now, babe.
We're gonna do it later, baby. Come on.
What? Why?
Busy right now.
Daddy's busy.
So Cosmic Zig asks, where is the data? You said it was open source. Yep. So it's right here on my GitHub. And how'd I clean? So this analysis 1 variables and regression is my cleaning file, basically, or Wrangler, my Wrangler. So you can see that how do we get data? The first thing you do is you just read the CSV, right? Then we do some string replacements. So on my survey, I say like strongly agree, and that actually needs to be turned into a 10. Strongly disagree needs to be turned into a 1. I rename a bunch of things just for parsimony. Like also all the spaces present pains when I'm trying to write out a regression formula. So I like collapse these variable names basically. That's the next step of cleaning. One of these, so here's ocean. So if we look at the raw data, ocean is a personality measure. It's the big 5 personality. So if you look at how this was entered, it's comma separated, right? So that's another thing that I clean or I wrangle here. I actually like the term wrangling more because cleaning implies that there was bad data. But wrangling includes feature engineering in addition to feature cleaning. And there is a bit of feature engineering, like a square variable. So anyway, here you can see I split it into 1, 2, 3, 4, 5 different variables. And that's really wrangling, not cleaning, right? Because these are not necessarily bad data. They're just not in a format that I can work with. So I split it into these, and then all of the strings, I numerize them. And then here I engineer some features. So one question that I ask is like, hey, are you familiar with these online course providers? I ask about what, Udacity. Have you heard of Udacity? Have you heard of Udemy? Have you heard of Pluralsight? Have you heard of LinkedIn Learning? Right? So technically these are all different variables, but they're not really meaningful in and of themselves. What I do is I engineer a feature where I count how many online courses the person is familiar with. 1, 2, 3, 4, 5, 6. And then this person is 1, and then sometimes it's 0. So that, again, it's not cleaning, it's engineering. And so here is where I define the familiarity count. And I compute it this way. There's like a little function here. Is large firm size. So there's a categorical variable for firm size, and I just pick out the Boolean. is serious. This is an interesting one where I decide whether I think your response is basically fraudulent. So in the raw data, some people just like responded 1. Let's see if I can find one. So this is ugly because it's using the strings, not the numbers, right? But you can see they just put the same thing like every time. So I basically don't trust that person. So I create a flag identifier for people like that, where I say the variable is called is serious. Like, are they giving serious responses? And I have a Boolean yes or no. So I would say that the person who just put 1 every time, I would say that they are not serious. And yeah, if you go back in the playlist, I am building and covering this file in detail. You can review this file in detail. It's open source. But I think that does a good bit of the answering about how did I clean. One other thing that I would call out that's important for the cleaning is that I did deskew. So I removed skew and that deskew. So get deskewed data starts out by getting all the data. Then I drop other gender because n equals 2 is too small. And then I drop if they're not serious. And then I drop if their hireability is less than 5. And this is the deskewing thing. So hireability is a measure from 1 to 10. So you might think that dropping less than 5 would be substantial, but it actually only drops like 2 observations, which shows you how skewed the distribution was. But for those in the range of 5 to 10, the distribution is relatively normal. And that analysis is done here in the exploratory analysis. You can see I did skew testing and also checked the kurtosis. So that is arguably, yeah, you could pretty much call that cleaning. And this constrains my analysis, right? So my analysis was originally targeted at, let's say, all American adults. And this modifies my coverage so that I'm only covering about 90% of American adults, maybe 90 or 95, but not 100%. Because certainly there's a solid 2 to 4% here. These, I don't think this actually damages our coverage, but there's like another 2 or 3% here. So yeah, so like 4 to 7% uncovered basically. And I'm okay with that because whatever results I do find are holding for over 90% of the population, so they're still important results. So I'm very happy with my coverage level. Okay. Let me check the chat here. No questions. Cool. So all that background, now what we want to do is build this multiple regression. So we copied over these factors, and we also need to grab, oh yeah, why did I prefer this one? So I really kind of would prefer this one, except it requires too many variables. If I do a naive thing where I just divide explanatory power by the count of variables, then I end up with a weak model. So my third solution is, well, let's not optimize on r squared per variable. Let's try to get as close to r squared as we can without significant loss of explanatory power and with an acceptable number of variables. And so that's how we end up here, because you can see I drop a lot of variables from 6.6 to 6.5, and that's basically like a non-noticeable difference. We would say it's an unimportant difference. It makes no, in the day-to-day operations of a business, it would make virtually no difference if they were paying 66 cents on the dollar or 65 cents on the dollar, right? Although it would make a big difference, 66 versus 50, right? So this is where that notion of economic importance comes into play. So it is somewhat arbitrary, but there's also a rigorous way to do this, which is the concept of normal profit or normal return. So the normal profit or normal return in an economy, at least in the American economy, is like around 7%. And so the idea is I can just put my money in the stock market long term and earn 7%. So that that becomes like an important watermark, basically. So if I was at 0.66 and then we go down to 0.59, hey, there's an important loss of money there. Do you see? But from 6.6 to 6.5, there's really not an important loss of money. If it's within my capability, I'd love to squeeze out that extra penny, but it's not a big deal if I can't, right? So I even accept going down to 6.4, but what you notice is when I'm adjusting my ratio, there's a sudden drop off from 6.4 to 6.1, and that feels like too much to me. So, so that's why I prefer this one, because it's unimportantly different from the best model, but it has a reduction in variables of about 50%. So here I have 81 variables. 50% of that would be like another 40 variables, so 121. So it's not quite 50%. I guess it's more like 40%. That would be 32. Yeah. And then you end up dead on 113. So I can increase my variable count by 40% to get 0.02 r squared better. And so the gains to explanatory power for the cost of the variables is not worth it to me, in particular because I'm constrained by the number of samples that I have. But just like, that's just not a lot of gain anyway for a lot more work. Let's say that you're in the real world, you're having to go out and collect this information. You're having to collect a ton more information to get just like a tiny little gain, right? So I think it's quite reasonable to say that this is like going from the 6.4 to 6.6 is just not worth the squeeze. Yeah, if I end up with another 1,000 samples, I'll do it. But until then, and realistically, I don't think this is going to make a statistically significant difference to any of my findings for gender variables as well. Is another important thought here. Whatever finding that I have for gender, say that we just add this on as pure error. The .02, say we consider that as pure error. If 2% error destroys any of my gender findings, they weren't very good gender findings, right? You need to be robust to a better level than that. If changing your data by 1 or 2 or 3 or even 10% is going to ruin your findings, you probably want to implement some additional robustness into your analysis. And so you can see here I'm doing leave one out cross validation is already robust, but then I do it with and without interaction effects. And then I have a slew of other sequential factor selection. So I'm doing robust analysis here. So my findings are not going to get thrown off by a 2% change in my data. So that's another reason that I think that this is worth it, where 6.1 starts, I'd be okay if I like gun to a head. I might be okay with 6.1, 6.0, because we're still around 10%. But this is where I start to get really nervous. And then certainly under 6.0, I would be very nervous because we have the normal profits problem. And we also have the problem where we're saying, hey, a 10% change in your data will wreck your like a 10% change in your data really could wreck your findings. Like that would not be surprising. 5% is kind of borderline. Under 5% would be surprising. And so with this 6.4, we're well under that 5%. So I don't feel nervous right here. And the same logic basically applies over here, where I'm looking at, hey, oh no, actually in this case, I was able to prefer the ideal model, which is really nice. So the R squared is 0.71, and nowhere is it better. And in that 0.71, there are 48 non-zero, so I can just select that one. 48 by itself, I could totally analyze. 81 by itself, I could totally analyze. But when you add them, now we have 129, or do we? Because these variables might very well overlap. That's overlap. Like they might have identified the same variable in some cases, so that I could end up with anywhere between 129 or 81 if they totally overlap. And same thing over here. This is like another 20 or so variables. So am I looking at 150 variables or am I looking at 81 variables? And that is the point of my current analysis in this dfx, which is, what does that even stand for? I should probably rename this file if I can't remember what it stands for. I'm going to call this reduce to preferred. Reduce to preferred M. So I'm taking all of these variables that I've identified in different ways as potentially important and saying, hey, which of y'all are the most important when I compete you against each other head to head? Okay, so I need these 81 variables. So like, what are these 81 variables? I need to know that. Oh yeah, it'll print it out over here. So I'll just run this file. You can see it's logging out some information in the file. And variable names, and that would be this line 174, and then it prints out the names of non-zero. Let's just double check. This is in association with the L1 ratio of 0.04, which is not my preferred one, so it's a good thing we double checked. So the L1 ratio that I prefer is the 0.015. So let's run that model again. Tyler joined. What's up, Tyler? Okay, so let's just verify the results that I previously found. So r squared of 0.638, and I said 0.64, so that's just rounding. Non-zero is 81, and gender variables is there's just one because there are no interaction effects, so there's just the one gender variable. Cool, so we verified this is the line in question, and so let's grab these variables. Just highlight them, Control C, go over here, Control V. That's it. I'm dumping all of these variables into here. Now, one thing to notice is that the syntax right here, this is stats model OLS from formula, and then you put in your formula. So this syntax is not valid for the stats model formula. So what I would need to do right here is I would need to like turn this into a true categorical variable. So it would be like, this. Right? So I'm going to have to go through, and that is also called cleaning, where you take an invalid syntax and you rewrite it into a valid syntax that means the same thing. So we are going to have to clean this formula, and we'll do that later today. But first, I'm going to collect all my variables, commit that, and then clean it subsequently. So one thing at a time. So we've gotten our leave one out cross-validation without interaction effects. We have gotten our non-zero effects. Now I need to do the same for the with interaction effects. And let me double check. So the L1 ratio here is 0.05. And that is not the preferred one. So I'll kill that process that I just kicked off. So we're going to go for 0.09. Hey, I appreciate the likes. Thank you very much. Ayo, the pizza here joined. Likes from high on definition. Thank you so much. Hey, so if you're watching on TikTok, I'm trying to use a wide angle lens on my iPhone, but I realize it's hard to see. So you might consider joining me on YouTube or Twitch. Let me bring up the YouTube channel. Here's the playlist where I've been writing this research paper. And here's my channel, John Vandeveer. And you can see we're streaming now, and you'll get to see the monitor much better, and also my face. Okay, so that process is done running. So let's verify the model. So we said .09, so I'm expecting, so the .09 L1 ratio, I'm expecting an R squared of 7.1. There it is. Count non-zero 48, there it is. 11 gender vars, there they are. So we've verified that this line is corresponding with the current log on the terminal. So now I will copy all of that, come over here, and paste it in a space. Cool. So all of these variables, how many lines of spacing do we have? So here's 1 and here's 2. So other than those 2 lines of spacing, there are 168 minus my starting line of 15. So 168 minus 15 minus 2. So up to 151 variables here, which would be a huge problem because I don't have that many samples. But we can immediately tell that there's some dupes, right? So here I control F and it's 1 of 1, so that's non-duplicative. 1 of 1, non-duplicative. 1 of 2. So that was found in multiple analytical modes, identified this variable, which is a good sign that that's going to end up being like a truly important one, right? But we can't get there yet. We have to actually run the model. But intuitively, we would guess that probably that one is at least more likely to survive than, say, these other 2 that were uniquely found. So we can eliminate that dupe, and there are not 151 variables at that point. There are 150. So we'll proceed in cleaning that way. But first, I want to commit the current changes. And the main change here is before cleaning and file rename. Cool. Yeah, I noticed that issue. Good. Sharp eyes. Love it. Do you write with Python, or what is your preferred language, if any? So this is going to be the boring part. I'm just going to go through and find the dupes and delete them. Sometimes stats is boring, y'all. I got to tell you, like, I'm a huge fan of statistics, but sometimes it's boring. Ooh, found 12. Okay. This is not a complete variable. Yeah. Also, I need to rename it. So the gender male is the categorical name for that variable. So get dummies. This get dummies method is where I take a column and I create dummy variables. That's literally what they're called. In programming, we would say like Booleans, but in statistics, they are called dummy variables. So gender male would be 0 if not and 1 if true. So it would be a Boolean or a dummy variable. The dummy is created right here. Get dskewed data with dummies. And you can see df with dummies. So this is using get dskewed data with dummies. However, these that I dumped are coming before the dummies. They are coming from get dskewed data, not from get dskewed data with dummies. Why is that? The reason is for parsimony, basically. If I split all of these categorical variables into dummies, in, like, consider the case of the United States. I actually have a state variable. See, New York, North Carolina, Pennsylvania, Tennessee. They're identified as potentially important. I can use the state variable when I write my formula because it is a categorical variable. But if I split it into dummies, now I have to write every state. So it's not parsimonious, it's labor intensive, it's time consuming. So what I do is when I'm identifying features, I use this get skewed data or get deskewed data that has none of the dummies, and then I only construct the dummies after selection. That way, say I might need to write 1, 2, 1, 2, 3, 4 by hand instead of 50 by hand. Does that make sense? So I'm doing that at the last step for reasons of parsimony. And labor productivity. Ooh, fancy words. So all that being said, gender male is the dummy form of this. So this is the categorical representation. It's the gender variable with the male sub-selection. It's the gender variable with the male sub-selection, which is equivalent to the dummy variable for gender male. Does that make sense? You can see how a categorical variable, if I could pick male or female, but then I could split that into 2 dummy variables that are 0, 1. And those are mathematically equivalent. It's just a difference in writing. So that is why I will proceed to replace this with its dummy form in all 12 instances. And in fact, I've already done that for several instances, you can see. So there, so I've replaced that. We will leave this variable here, but I think ultimately that will be deleted. But we will let the statistical software handle that because I have all of these gender effects. And so they're going to be, by construction, they're going to be collinear with the non-interacted measure. But it's possible that the non-interacted measure is independently important. So I'm not going to assume anything. I'm going to let the statistical software handle that. All right. So we're into education, ethnicity, still not duplicating much. Okay, this one's duplicated, but you can see here it's by itself, and here it's interacted. And the interaction appears twice, so I can delete one of the interactions, but I would not want to delete the I don't want to delete the non-interacted form because it is duplicate with an interacted form, because those are actually different variables. They're related, but different. Cool, so that's duplicated. I think this is, the syntax is like that. Rule breaker effects. So all 3 rule breaker effects showed right here. So that's interesting. Okay, favorite programming career. But those are all different ones because you can see those are all interactions. So I suspect the interactions are going to be more meaningful than the independent measure, but that's just suspecting. That's not, so I'm going to let the software handle that. Okay, so personality OCEAN. So all big five personality measures were identified as potentially important. They have some level of importance, and they were all 5 reselected in the elastic net with or without interactions. So should surprise nobody. It's more of a replication than a new finding. Personality matters. Hello? Hello? Personality matters. But all 5 of these are duplicatively identified. So I'll remove all 5 of them from here. Boom. Worldview continuous activism. Activism is duplicative. Cool. Huh, that's interesting. Progressive Christian is duplicatively identified. Look at that. It's a little surprising, honestly. Innovation bias is duplicatively identified. Regulatory favorability, those are not surprising. If you favor regulation, are you going to be in favor or against alternative credentials? Well, alternative credentials are unregulated by definition. So it's very intuitive that if you support regulated education, you're not going to support alternative education, right? You're going to be like, hey, people need to go to accredited university, not woo-woo boot camp, right? That's very intuitive. I don't believe that, but that's a very intuitive way that some people think. Poppy Sensei, what's up, Poppy Sensei? Nice name. Prestige matters. This is not surprising. Okay, we got physical attractiveness, written communication skill, body language, break rules, and commute. These are all duplicatively identified. Cool. Did we make it all the way through? So we made it, and then we made it all the way through the skills, but not through the no relative overqualification. Wow, this is very surprising, actually. So that's surprising enough that I need to go check and see if I did that right. Because it's saying that no comparative skills were identified at all in my elastic net over here. Yeah, so I just have to check if they were even tested. Because it's like, if none of them were found at all, then it makes me sus were they even tested. Because comparative skills are like a big deal in the normal world, right? So these were all tested, and none of them were identified as particularly important. It's pretty surprising to me. Okay. I'm going to write that down as a note. That might constitute a finding. I have to think about that more. Results. So here's my results, and I'm just going to make a note. Note. Elastic net that tested with interaction effects Yeah, so that's a really interesting idea. Maybe so did the interactions partial out the comparative skill gaps? That'd be weird, but it's possible, so I need to think about that more. Are you typing with one hand? No, I have my iPhone is sitting on like a iPhone holder thing. That'd be dope. Okay, so and then these gender ones. Bum, 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 bum. Ooh, that was duplicated, huh? Nice. Finally. So this is interesting to note. So the only, there were two. This is another interesting note. Note, only two gender interactions were duplicatively identified between SFS and ElasticNet. And that's these two. So there's arguably something special about information technology, and that's not mysterious to us. Thoughts on behavioral economics. It's awesome. Thoughts on behavioral economics is that behavioral economics is awesome. So do you see that I have personality variables here? That's because I care about behavioral economics. And notice that they were all significant. Grit, it matters. Conscientiousness, extroversion, neuroticism. It's almost like your personality matters, isn't it? Imagine being an economist and not understanding that personalities matter. What favor programming career, whether you actually prefer it. Risk seeking. Okay, classical economists acknowledge risk seeking at least. They don't really consider that a personality measure. But absolutely, you need to account for norms. So I have prestige in here. Where's prestige? I call it like other impressed is what I call it. And what I mean by that is, if I tell you I went to Harvard, are you impressed? So if you're impressed, and if Jim is impressed and Sarah and like everyone's impressed, that constitutes a social norm. It's normal to be impressed that someone went to Harvard, right? So we need to account for that. Because if I ask you, hey, what do you think about coding boot camps? The odds that you're just making an optimal economic decision, like that's not how your thought process really works. You're going to consider social norms, and you're going to consider like a whole bunch of stuff. And it's going to depend on your personality. It's going to depend on a whole bunch of stuff. I'm going to one. What do you mean? Oh, you're going to a boot camp? Cool. Good news for you is that they work. Yeah, Full Stack Academy, it works. It's pretty good. So you're going to have a job, no problem. If you have any problem finding a job at all, hit me up. I'll get you a job. But you should have no problem because that's a decent boot camp. So yeah, behavioral economics. Look, it has a bunch of problems. I know there's the theorist who keeps saying that like everything is inefficient. It's like he doesn't understand his own theory. I don't want to get off topic here. Where's that guy? It's like a French guy or something. Leibson, yeah, not Leibson. He's not who I'm thinking of. And Selly, no. It's like an Italian guy or something. Dan Ariely. All right, so this guy, he's always talking about, oh, behavioral economics is true, therefore economies are inefficient. Bro, you don't even know like how your own theory is working. You get into problems like that where it's like, you know, they did good research and then they analyzed it wrong. Predictably irrational. Let me tell you, behavioral economics does not mean that people are predictably irrational. That's not the result of even his own research. So he misinterprets his own findings. He keeps using this term irrationality. It's like you keep saying irrationality. I don't think you know what it means. This should just be called predictable, not predictably irrational. It should just be called predictable, or the upside of predictability. So yes, people have these biases, like their personalities bias them. They're biased by social norms. They're biased by prestige. That doesn't make them irrational. It just means that they're predictable along certain social lines. How much did the keyboard cost? Oh, I don't know, $30 or something. Ooh, pretty cool, right? So anyway, behavioral economics is really important, but don't mistake that into thinking that every behavioral economic researcher is like a demigod, because there's a lot of idiots out there. There is a lot of idiots out there. But behavioral economics itself, extremely important, and the data shows that. The classic neoclassical assumption of economists that personalities are stable, we have strong evidence that that's not the case. Personalities throughout the lifespan of a particular person are dynamic, and personalities at the collective or social level are also dynamic. And those are important effects. Cool. Okay, let's continue. I'll give you 20 for it. Get out of here. Okay, cool. So yeah, it was an important result. The thing is, I don't really understand retail. That one baffles me. I guess my guess would be, my guess would be neg coefficient on retail, just because who needs alternative alt ed or higher ed for retail? So that's my best guess, but the gender impact there, it's like, what? I don't know. So we'll see if that turns out to be what it is. Cool. So we have this regression that we're currently reducing. So we removed all the duplicates, right? We already did that. Okay, so this is one more duplicate I need to get rid of. Information technology was another one. Yep, got rid of that. Cool. So we have eliminated the duplicates now. So we were worried about having, what, 151 variables. Now it looks like we have under 130. So it was 140 minus 15 minus 2. I think it was 141. So the good news is we cut out about 25, 26, 27, something like that, duplicate variables. And that's a good thing. Like, duplicate variables, isn't that bad? No, it means our different ways of doing analysis identified the same factors as important, which is a good thing. It's a robust result. We have like multiple different studies showing that these factors are important. So that's the good news. The bad news is that once you remove all the duplicates, we still have more independent variables than samples. So we need to do more feature reduction, feature elimination. Let's see, how can we do this? The first thing I'm going to do is just commit where we're at. So this would be remove dupe important candidate features. Okay. So we're committing that, pushing it to GitHub. And the second thing that I need to do is fix these namings, right? So we talked about this is a categorical name, and that categorical name cannot be interpreted by the from formula function. It's not a proper formula. So we need to rename this categorical variable into a dummy variable. So how do we do that? We go over here and let's add some dummies. So we got A, B, C, D, E, F, G, H, I. I like to have these in alphabetical order because I'm like kind of autistic, right? So there's gender and industry, and now we have expected duration. Okay. So there's expected duration. And I like to do these two at a time, and then industry is going to be another important. Did we already do industry? Okay. Cool. Job title credentials is another one. A, B, C, D, F, G, H, I, and J. Job title credentials. Boop. So I'll just do two at a time, because if I do too many, then there's like too many errors. Because when I do this, it's going to create an error, and then I have to fix it, right? Because when I create the dummy here, like if I create the expected duration dummy, it deletes the expected duration column. So this column will no longer exist, and that generates the error. It's going to be like you're looking for this column, but it doesn't exist. And then we will get the dummy name. Invalid syntax, moderate negative impact. Oh, yeah. So I'm going to double this variable. Boom. We'll call this cleaned. Because, as I said, this is not a syntax that it can understand. So we will only want to include the variables after they're working. Cool. So let's get rid of all of these. Boop. Let's just get rid of all of them, I guess. So here's the cleaned one. But it doesn't really matter. What we want to do is grab the dummy name. So it should be like expected duration underscore something. It's still it's not printing it out. So here I print out help build long model formula. So I print out before the dummies. Now I'll print out with the dummies. Cool. Try this one more time. Now I should see the dummy. Oh, North Carolina is still not there. Yeah, I don't know why it's reading that at all, because I'm not using that variable. Oh, I didn't hit save. Look at that. The circle in the top right means that I didn't actually save it. Oops. Cool. So this is a regression. It's just the intercept, whatever. But now we should see the dummies. Expected conventionality is right here. Oh, expected duration. There it is. Expected duration more than a year. So that's a dummy. That's the dummy name. Now, which ones do we want? We want 3 months, 6 months, excuse me, 3 months, 6 months, under a year. And then we can grab these industry ones, and there's the job title. So we can grab all those. Boop. Let's grab those, throw them down here, and rename it. So, by the way, I can't include all of the subcategories of a categorical. That will lead to perfect multicollinearity. And that's a statistical problem because in statistics, if you want a coefficient, you need variation. You're explaining variation. So if I say, hey, everyone's a guy or a girl, and I have a variable for if you're a guy and a variable for if you're a girl, I can't run a regression anymore. All I'm doing now is I'm just telling you which group you're in, right? There's no variation to be explained. It's just like by definition, which group you're in. So we have to leave one out. So expected duration is a categorical variable. All of these dummies exist under it. More than a year, under 3 months, under 6 months. So I gotta drop one of these, basically. These are the ones that are potentially important, so I don't want to drop any of them. So I want to pick one of the others. 3 months, 6 months, under a year, under 3 months, under 6 months, under 3 months, under 6 months, under 3 months, under 6 months, under a year. I think I will drop more than a year. And it's pretty arbitrary, isn't it? But that's the one I'm going to pick to drop. So drop first dummy is true by default. And then, so for industry, we're dropping agriculture just because it was the first one on the list. In alphabetical order. And we're doing the same thing with more than a year. We're just picking the top one. And I think I'm going to do that like every time unless the top one is identified as potentially important. So expected duration, gender. So we're dropping gender female. Yeah. So it is kind of awkward because it's like, don't you care about the female effects? It's like one of the main things we're concerned with. But all of the effects here were identified as male. And I think it's for the same reason. I think just internally, the software said, oh, female, male, we need to drop one, let's drop female. And so male is remaining. But the fact of the matter is I can't just go in here and change that to female. Like that will ruin the statistics because that's actually saying something very different. So I just need to preserve it as male. And so therefore I need to drop the female in addition to the fact that it's consistent with our pattern of just dropping the first one. Let's drop that, drop female, drop agriculture, and then we will drop I do not know. So job credentials, it's like the I do not know answer. So we want to make sure that that's not important. And it does not appear to be important. So we will drop that one. This is like not parsimonious, so I think I can reduce that. So we'll go to the variable renaming. So here's job title credentials right here. Oh, actually, here's a reason that we would not. So this is no, I do not know of any credentials which are common, valued, or legally required. It would actually be better to drop the not applicable answer. Possibly. So think about like a question like, does STEM matter? And there's like, and I ask you, do you work in a STEM industry? Let's say I ask you if you work in a STEM industry. So one answer is like yes, the other answer is no, and the other answer is I don't know. It would be best if we drop the. It would be arguably best if we drop the I don't knows, and then we have a clearly defined value of yes or no. Instead of the other thing we would do is like there would be an implicit value of yes or no, which is kind of hard to see, basically. Thinking about the job title provided. All right, so I'm going to replace that with just R. So let's run this again, and these should be shorter, and then I will I'll drop this guy. A, B, C, D, E, F, G, H, I, J. Hey, what's up, Jesse? This is my sister, y'all. Kind Jester. It's like it didn't work. It didn't get any shorter, did it? Job title credentials. Oh, I need to do, I think, one of these. Certification, license, or. I think I'm writing this wrong. Hey, thanks. Thanks for the birthday. Yeah, why is that not working? Certification. Huh, it's not making that any shorter. That's no good. Do I change the name of it later? Let's just do the word Non-degree. Oh, I think because non-degree gets changed later. Okay, so I bet this works, right? Certification, foo bar. No, that didn't work either. What the? What's this? Thanks for asking. So I'm writing a research paper. We're trying to understand, hey, how can we get more women programmers? Why are there so few females in computer science programs specifically? And are there things that we can learn from coding boot camps specifically? Reformat column names. Foobar, that time it worked. So I don't know, I'm gonna just put it here. I don't know exactly when I'm changing that variable name, which is not great, but I know how to fix it, so woohoo. So we'll do this right here. All right, cool. So R, that's much shorter, right? And then the dummy will still be this one. Cool, there it is. So far, so good. And so which ones are actually over here? Yes are an industry norm. Yes are required by law. So here is yes are an industry norm, and there is required by law. See, it's like a nice, concise variable name. This should be industry underscore manufacturing. This will be underscore information information technology. Under 3 months. So then it's under 6 months, under a year. Finance, investment, or accounting. There's health. Okay, 3 months, 6 months, years. All right, so I'm expecting this one works with the candidates cleaned. Let's see. Cool, so it works. So here's the regression. It's just with these variables, so we're not obviously not done. But it's running fine, no errors. 3 months, whatever. Cool. All right. We already got manufacturing jobs. So next would be manager effects and state. So I got kicked out of my house for drinking beer. I really need a dev job, man. Ah. So here's manager effects. Like Frog Fan AC got kicked out for drinking beer, and he seriously needs a job, a dev job. How do I support myself? I mean, the first thing I would say is it sounds like you got other stuff to work on before you try and get a dev job. So getting a dev job might not be super easy. You could start by getting like a Walmart job, Target job, something like that. If you're at Starbucks, maybe a Starbucks job. No joke, because Walmart, Target, those people, and I think Starbucks, you can go to college for free while you're working there. So you can get that programming degree, and you can also earn money and pay for your own rent that way. So that'd be one thing. So I would say, like, if you really need a job ASAP, try and get a job at like Walmart or Target. But if you really need a dev job, dude, just start coding. You know, good luck getting good help though, because like good help costs money. Like I tutor people, but I'm not free. And I got to tell you, I got kicked out of my house for drinking beer. Isn't like a really great selling point for a pro bono charity case. There's plenty of online, like Free Code Academy. You know, I know you've tuned into previous streams of mine, so you've probably heard this, but like Free Code Academy is probably the best free one. Do my services help? Come on, of course they do. I help people land jobs. Yeah. So for just like a random hour, I charge $100 an hour currently. Stuff changes over time, but you can message me. Here, check this out. Laterally. So go here and set up a 30-minute coding consultation. So like if you end up doing a whole learn to code and land a job like package, I usually give a pretty good discount. Yeah, 8K is way more than enough. So I charge less than Bootcamps for sure. Although you make a good point because like General Assembly, like you could maybe do a boot camp, right? General Assembly is pretty good. Course Report is like the search engine that you can go look for different schools and like find highly rated ones and stuff. Lowagon's awesome, but they're French, so they're not in the US. App Academy is really good. So check those out. Or I usually just tell people to make a portfolio to get a dev job. Yeah, that's right. The problem is like, how do you make a portfolio if you don't know how to code? So you're right that like a portfolio is the best tool to help you land a job. But you need to know how to code before you can make a portfolio. And a lot of people can learn that on their own, but a lot of other people need help, you know? Let's see, Ario Speedwagon said, what you making? So I'm making a research paper, trying to understand how can we get more female programmers. So here's manager effects. What was another? State was another. Cool. So here are the states, and we will drop Arizona as the first state. Manager effects, no. I'm going to drop unemployed. Again, that's just to make the interpretation easier. If we think about whether you're a manager, the intuitive thing is to say, well, either yes or no. It's kind of unintuitive to go, oh, well, you might be unemployed, so it might not be an applicable question at all. So if we can eliminate that category, it makes the interpretation easier. See you, Jess. Okay, so manager affects unemployed, state Arizona. So these are the ones to add next. So manager affects, yes. Oh, hey, Frog Frank, just sign up for a consulting session. It's free. We'll figure out what's best on a call. Link it. I thought I already linked it. Okay, let's link it again, I guess. Oh, you know what? Did it not go through to Twitch or something? Maybe it didn't go through. Enrolled. It's because I'm signed in my admin mode. That's no good. So incognito, so it doesn't know, and then I'll go consultation. So this is where you would sign up. All right, cool. So state New York. It's just state New York, right? I'm like lagging or something. That's no good. North Carolina. Pennsylvania, Tennessee. It'd be cool if somebody else did an analysis of these states. Like, what do they have in common? Because I don't really know. Okay. Income. So we will drop the 0 to 99.99. All right. And age, that's the next important one. Income, age, education. Let's grab all these. Okay, so 100 to 124. All this talking is making my throat hurt. We got age and education. Is this programming? Yes, this is. What's up, Aaron King Paul? Doing data analysis in Python. See you, Frog Fan. See, age, this is another one where the first one would be 18 to 24, but that's a really important age group. So I'm going to drop age 65. I'm going to drop age 65 plus because, to put it crassly, it's like if we're thinking about alternative like education, it doesn't really matter too much what these people think. Like, this age group is largely retired, and they're certainly not, and they're like very rarely interested in education for the purposes of landing a job. Is this programming for work or school? Neither one. Whoa, surprise. So I'm an independent researcher, and I'm presenting at the Southern Economic Association conference. I guess you could say it's for work, kind of. It's related to the business that I own. It's not related to my job. So this is the SEA conference I'll be presenting. I feel like my computer is lagging or something. Or maybe it's this website. I don't know. Anyway, Southern Economic Association. I'm presenting in it later this month, so it's for that. And I do have my own Latterly.io where I teach people to code. So I definitely use my research there to help people land jobs. But that's not my full-time job. So, but it's kind of, I guess it's kind of a job. Okay, so age, we just said that we don't want to drop the early age, and then it was education, and what was the other? Age. I think age and education were the ones that I added. Income, age, education, but income's already done. So age and education. So for education, did not graduate from high school. Yeah, I'll drop that because honestly, and if you got your GED, that's another group. So this is people who did not graduate from high school and did not get a GED. So honestly, I'm not, I don't know if it's like a competitive option for them to go to a boot camp or whatever. Yeah, I'd probably push that person to try to get their GED first. This is a small group of people. Any group of people you pick, it's going to be kind of crummy because you want your analysis to apply everywhere, but like that's not how statistics works. Okay. And age, what age group? Oh yeah. So this is like 35_44. Here's high school diploma. Obtained non-doctoral graduate degree. And undergraduate degree in some college. Cool. Yep. Education, age, income. Got it. So let's see if that regression rolls. Yep, made it through. Notice some of these p-values are wicked high. So these are candidates to be cut. But we don't want to cut them yet. That would be premature. So ethnicity and worldview description are up next. Okay. Here's ethnicity. Worldview description. So ethnicity, the first one is American Indian or Alaska Native. So we'll drop that. And the worldview description is agnostic or atheist. Okay. And so then these effects would be Black or African American. And description would be religious but not Christian. Went through just fine. Cool, cool. I'm going to do a kind of a work in progress commit here. This is clean model whip. Is this coding or something? Yes, it is. So we are doing data analysis in Python. Oh, did I not save that? All right, cool. Let's see. We already did education, I think, right? So now we're on to COVID factors. And then a bunch of those are non-categorical, so we can just copy them over. Why are those worldview description factors out of order? That's suspicious. Oh, those are interactions, that's why. Okay, that's not so suspicious. Okay. So we can grab all those. Yeah, really, we can grab the rest of these. That's awesome. So COVID fave online, and COVID remote, COVID impact. These are the three. COVID fave online, COVID remote, COVID impact. So large degree, let's see, which COVID fave online? No increase or a slight slight degree. So I'll drop moderate degree because I still want to be able to investigate a large degree. So can I drop moderate for all these guys? So fave, remote, oh, no. Here, I need the moderate. So I have to drop large to be consistent all the way across. All right. One, two, three. So COVID fave online, large degree. COVID impact, large. And COVID remote, large. 1, 2, 3. All right, so let's replace these. So this is no increase or a decrease. What are you doing? Hey, doing research. So this is Python. We're doing stats model regression, writing a research paper. We're trying to figure out why are there so few like female programmers? What can we do to get more female programmers? Fave online, slight degree. No increase or a decrease. COVID remote. No increase or a decrease. And this is COVID impact, slight. This is COVID impact, moderate. Cool. All right, so will this run? We got a bunch of things going on here. Oh, no, that one needs to be replaced. So these, other Christian, progressive Christian, religious, not Christian. Okay. Let's see. Will it run? Does using the computer screen too much cause eye problems? Maybe. I don't know. Okay, so it's mad about this parenthesis. Hmm. How about now? Cool, that worked. Hey, also, now that you jog my memory, I think Huberman, yeah, this guy, I think he recommended like for every 2 hours that you're in front of the computer, get 5 minutes of outside time to help. Yeah, so I think he said that would help prevent eye problems. Bam, look at that R squared. All right, so that's the first group of factors. Here's the second group of factors. And the third, why not? Let's get all of them. Boop. Let's see. I'm trying to think through what is this going to do because I think this won't work very well. Because I'm going to have too many. I'm going to have too many variables. Maybe I can go group. Maybe I can go group by group. See, number of observations is 86. See, because there's partial responses. One 46, 225. Really got to go minus. Minus one more for the constant factor right here. 225 minus 146. 225 minus 146 is 79 variables plus 1 for the constant is 80 variables. So you see there's 80 variables, but there's 86 observations. So I can really only afford like 5 or 6 more variables here. So y'all see the problem? So basically we have to go stepwise. Ew. So what I want to do basically is reduce this first group further. So one way to do this is sequential, kind of like sequential feature selection. But another way to do this would be to prefer a model with fewer factors. So we did 81. So we can cut some. Like this guy shouldn't be here. Why is this guy here? Because apparently it's good for prediction, but it's not good for it's good for prediction, but it's not good for inference. Backwards elimination. Cool. So we are going to cut some of these where the p-value is too high. What are you doing? Doing research. So they're like coding boot camps. About 40% of the enrollments are female, and computer science programs about 20% are female. So why? Like, is there something computer science programs can learn from boot camps? And then industry employment for female programmers is also very, very low. So is there something that they can learn from boot camps? Like, what can we learn to increase female enrollment in school and or female participation in the programming labor force? So this is a bunch of statistics basically, and we're using Python. Stats model, pandas, that kind of stuff. Scikit-learn. Yep. Thought I could escape code on TikTok. Thanks for the follow. Appreciate the likes. Hey, I don't know if y'all know this. More likes is how the video gets around. So if you don't want other people to see this, Jesus Chrysler, just don't like it. But if you want to spread the message, tap the screen and get those likes over there. Okay, so we're gonna start. This is gonna be step 1. Yeah, we'll call this reduction step. We'll call this reduction step 1. Might want to make a diagram of that. Okay, so here's reduction step 1. And we'll put some notes up top. So r squared equals 0.98. AR2 equals AR2 equals 0.68. AIC equals 96.67. And I'm going to ignore the BIC because I don't believe it holds in my case. And then the N equals 86. And how many variables do I have? I have 80 is after the plus 1. So K equals 80. All right, cool. And this is NX elastic net before cutting by P values. Expect it's overfit. All right, so this is reduction step 1, and now we're going to do over here reduction step 2. Give it a constant. It's going to be a function of hireability. And so how do we know what to cut? We start with all the things. And then we cut them if the p-value is over 0.5. And we start with the highest. So there's 9.5. There's a 9.51. The other was a 9.53. Here's a 9.83. So let's cut that 983. Personality N. And let's see if I can quickly. Morning Milk, what's going on? Hey, thanks for joining, y'all. Gender research in tech, what's the point? Yeah, so there are a bunch of like leaders in the tech industry that want to increase diversity. So the theory is that increased diversity leads to increased innovation. So I'm not examining that point, like that's a different kind of research someone else could do. That's really interesting, but assuming that's true, the question then becomes how do we make the labor force more diverse? That's the point that I'm focused on. I wonder if there is a good way to do backwards feature selection. If I could do this using a function instead of doing this manually, that would be a lot better, right? So this is forward selection. I don't want that. Backward elimination, yep. Cool, backward elimination. And then here's the awesome. Copy this. Somebody just did it for me. How great is that? So here is backward elimination, and we'll obviously give credit, so we'll ref that. And then they're using a 5% significance level. I'm going to go 10x that. 10x that bad boy. And so how is this function used? Just passing the data, huh? Return features. Here's output. Features with constant. Where does that come from? SM add constant. We don't need to do that. So this is return features. So this would be like reduction step 2 features equals backwards elimination of data. So we will be DF with dummies and target. What does target mean? So target is the model. So here I'm going to put supermodel, and I'll do OLS dot from formula. So this is getting all of the features. I'm going to do that differently, right? Okay. While, oh, I can't do that differently. Interesting, interesting. So while features is greater than 0. Yeah, so it's literally just using this array of features. Okay. So I would want to get the supermodel features, and it's going to initially be this, and then we'll remove one. Yeah. So supermodel feature pool. Even though I think the word supermodel is a little bit funny, I think it could be confusing technically. So I'll call this the, it really is technically a supermodel feature pool. It would be the unreduced feature pool. Feature pool features before elimination. Let's just call it that. So we initialize it to features before elimination and target what does target mean here? Supposed to be the target model, right? So I don't understand why this is being added with a comma. Oh, because they're adding the constant to the data set instead of to the model. Okay, I can roll with that. I'm going to put the features first because it just makes sense to me. Because from formulate, you put the features first. So features, data, significance level. That's all I need. Great. Here's the features. Modern Cody, copy, paste. Test, exterminate. Yeah, basically that's how it be. That's accurate, fully accurate. Okay. So here are the features, and then here is the data, and we add a constant to the data, and now we have, I would say this is like data with constant, not features with constant. Here's data with constant. And okay, so we don't do from formula, that's fine. So data with constant, and then we have features, no? We have target. What is target? Target variable. Okay, it's the target variable. It's not a target model, it's a target variable. See, here they just pass a formula.
You have to pee, so I think you do. So sit down, get that patience, and go pee. I know, everyone has to do it though.
OLSYX. OLSYX. Yeah, why can't I just do this? So yx. So they do yx. They're just calling this target. Okay. So this should not be features. This should be like y. Let's just call it y and x. Can we do that? That's less confusing to me. Okay. This is really great. So the difference would be that here I want data. So there's my x, and then what's my y? It'd be data features before elimination. And I will call this y name, or target variable name. Even then, it's like, what do you mean target? So I'll call this y variable name. So I think that works, right? So here's the degrees of freedom with dummies. The y variable name is hireability. And significance level, I guess we can specify as .5, but it's also the default. Okay. So let's see if this works. Reduction. This will end up giving me features. And then, like, yeah, like what is... I guess we'll just print that and see what it does. I don't know. Pretty much expecting an error, to be honest. Yeah, Boolean array expected for the condition, not object. 333, 319. 333, 319. So this is a problem. Boolean array expected for the condition, not object. Oh, because it's 2 columns, 2 list. Data columns, 2 list. Data columns, 2 list. And then so we get this is a data frame, so we get a sub data frame of this list, and then we add a constant, and that makes x. That makes sense to me. $322 is the problem now. So what's the problem here? Pandas data cast to NumPy D type of object. What? This whole pandas NumPy thing, super annoying. for target variable. Ah, okay. So here I should not pass the target variable name. I should pass the target variable. Yeah, I can totally do that, right? I can totally do that. So what's the issue here? Let's comment the while. I don't want any like infinite loops going on. Unexpected indentation. Okay. Pandas data. Okay, so it's still complaining. On line 322. Let's see about this. So that worked. It's just not helpful because it's printing all of the columns. Here, I just want to print y. Okay, so it did print, so it's there. That's what I expect y to look like. What are you doing? Doing research, doing stats. Try to understand how can we get more females in the tech industry, specifically in programming and possibly in computer science programs. See, boss y equals boss price. So 106 rows, length 106. So it's not like it's not like the length is incorrect. So here's the model. So it won't fit. Why is it not fitting? Line 323, line 322. Pandas data cast to NumPy D type of object. If X is your data frame, try using the as type method to convert to float when running the model. All categorical variables should be converted into dummy variables before sticking them into the model, so yes. All right, so the issue is due to categorical variable values not previously converted into dummies. Am I being hacked? Nah. Purpose of AI. Ask that question again. What do you mean? Like the purpose of artificial intelligence in general, that's like a very broad question. And I don't think there is a the purpose. I can tell you about the purpose of me writing this specific Python file. And that is that I'm trying to identify which gender effects, if any, are important explanations of hireability. Okay, so data, columns to list. So I think one problem is that this is getting all of the columns. That's not what I want to do. So this should be like initial features. Okay, yeah. Data. Yeah, I need an initial features. So this is candidate features. And so the way I can get this, I can do reduction step 1. Here's reduction step 1 is, so this is reduction step 1 features, yeah. Reduction step 1 features. And then this would be here's reduction step 1 model. Reduction step 1 feature names is going to be this dot exoge names. Now I have the feature names, candidate feature names, and so now it should not be considering categoricals. Okay, it's mad about the square. That's fair. No, what is the purpose of your program? Oh, that's cool. I would imagine a lot of variables factor into that. Yep. So I'm looking at over 100 variables. There's quite a few. Quite a few. Actually, I've actually looked at over 200. And it's mad about the interaction syntax. Damn, that's not good. So it's mad about this colon, and it's mad about the square, which are valid if I'm doing from formula, but they're not valid in this syntax. You know what? Maybe I can just build the string myself. See, it's not too hard to build this string. Why is this a capital OLS and this is a lowercase OLS? Oh, stats model formula. Okay, so OLS dot from formula. So formula equals y variable name plus, right, so that's the start of the formula. That'd be this bit, and then I want whatever, and then I want +1 at the end. So we don't need to do this X thing anymore. And we're not going to be doing this. We're going to be doing this. Okay. And then sort of as a placeholder, we will just do a single feature for now. We just do the constant, just to make sure this works before I go looping through things. Missing one required positional argument data. That's right. So here's formula, here's data. Okay. So there's the formula with just my constant, and then the feature names. Then we print the features. Cool. Cool. So this middle part, I need to use an iterator. I might be able to do one of these. S for S in. No, that's a list comprehension. I don't want to do that. I could do a lambda. I think just the print block is, yeah, something like this, just to join. Okay. So, exog, like exog names equals Um, all right, let's try this. Name intercept not defined, okay? What if I do... That's really interesting. What if I remove this +1? Will the intercept work then? Intercept not defined. Okay, so I will split out intercept. Python find index of string. Feature selection on what topic? Feature selection on the topic of labor economics. Yeah, labor economics. So the question is like, what factors influence hireability, and is gender involved in those factors? Either straight gender or interacted gender. So this is close, but I don't want the string index. I want the index of the string. So find. Yeah, I think it's find. No, that's more substring stuff. I think it's just the n keyword, right? Example, this. Thanks. Okay, so would be candidate feature names index is intercept. Cool, so we remove the intercept index and then we initialize to those features. What's up, strong boy? Thanks for joining. X not in list. List remove X. Where does it say list remove X? List remove. Okay, did I just get, I got the index and I didn't need to? Okay, so it removes the value of 9. I was thinking it removes the index of 9. Okay, so that's kind of good. So we can basically just do this. Can only join an iterable, okay? Python, Python, you're the best, Python. Oh, what lang is this? You didn't hear my song? This is Python. None type object is not iterable. This is super whack. Let me just see if I can print features. What do you mean none type? Get out of here, you crazy Python. Features is none? I find that sussy McSuss. Okay, so is this a void operation then? So let me do one of these. Sussy McSuss, that's all I can tell you. What is going on? All right, what if I don't remove anything? Yeah, see, it's right there. I do toList. Are you not a list or something? Okay, so now what if I remove index? So here's, or intercept, it's intercept. So here's intercept. I just want this to print with no intercept element. None. How does it go to none? All right, maybe it's a void operation. And intercept's gone. That's why, so it's a void operation. Thanks, Python. That wasn't confusing. Things that Python does that are not confusing. Okay, so now we have features. So let's go back to where were we? Let's draw the formula. So the current, so here are all the features. So then I'll call this current feature names. That's probably more, it makes more sense than current exogenous variable names, doesn't it? Okay, so current feature names is yeah, this is not well said. Current feature names should be here. Current feature names, current feature names, current feature names. So these are the current feature names, and this is the current feature subformula. Current feature subformula. Okay, and then we'll add the right. So we have the y variable name tilde subformula plus 1 gives us the current formula. I'm fine calling it formula instead of current formula. Hey, oh, did something work? Features is not defined. It kind of almost worked-ish. It worked through one iteration. It worked through one iteration. I'm quite happy about that. Python is so great. Can y'all help me write the Python song? Whoa, 950 likes. How do y'all like this? That's weird. Good job. Thank you. You guys rock. Check this Mocha quad. I'm on one. Thank you for the likes. All right, so we got it to work through one iteration. Look at that big old juicy R squared. Don't pay any attention to the adjusted R squared behind the curtain. Okay. Yeah, so features failed out. Okay, totally fine. Because we're calling it current feature names, because I think that's less confusing. So that was just, I didn't plug a variable in. Cool, so no errors. Okay, so we have gotten through single iteration. I don't need that, don't need that. So what we want to do is now, here's where it gets dangerous. we are going to throw it into a loop. So what are we doing here? We are getting, I guess I should probably test the p-values, huh? We'll just, if it errors, then we'll come back to it. I think this is good for now. So let's be a little optimistic here. So we're fitting a model, and then we want to get the p-values and trim one by one the bad features with the high p-values that suck. So here's p-values. Okay, p-value max, current feature names. So let's just pretend that this is going to work, and let's see what happens. Basically, this array should be a lot smaller. I'm going to copy that. I'm going to go to character count. You know what I can do? Here. We can just go to DevTools. What are you making? I'll answer that. Give me 5 seconds, dude. I got to var before trim equals, bam, before trim. And so you see, I can see the length of 80 right there. And so I just want the next one to be a lot less than 80. All right, let's run this and answer the gentleman's question. Bard Boimler. Did I say that right? I don't know. So this is backwards feature selection, backwards feature elimination. And so I have like a bunch of independent variables, and some are cool and some are shit, right? So I need to sort through them really quick. So that's what this does. So allegedly it's done already. Dude, if that worked. Var after trim. Look at that. It's already done. So it just cut through them like butter, babe, like butter. And so let's look at the most recent regression. And you can see here are the p-values, and they're all under .5. Dude, okay. Sometimes I hate on Python, but sometimes Python is sexy. That's some sexy Python right there, not gonna lie. And the R squared, look at that. Earlier, the R squared was like 984, and the adjusted R squared was like 6.6. So our adjusted R squared is like way bigger now. You smell me? Very, very happy about this. So I think this is a success. So I'm going to commit this before I go and wreck everything. I'm going to say feat backwards elimination. This is all open source. Some sexy Python, not going to lie. You can see that adjusted R squared is going up each iteration. 889, 895, 900, finally 904. Cool. And so we reduced to 67. So that's 80 variables, including the intercept. So now model important candidates. The point of this file is, hey, you identified factors that are important, but what are their directions of effect? Okay, so here is reduction step 1, and now we have reduction step 2. And I don't need to print that model every time. So here is reduction step 2. So here are the features. I can actually define get hireability formula, and that's going to take current feature names. And return this. And this will be called get formula. So there's the y variable name. And the current feature names. All right, so that saves us like a little bit of space here, but that's not the point. The point is I can reuse this over here. So reduction step 2 feature names. So here I'm getting the feature names, but I really want the whole model, right? So reduction step 2 model is going to be reduction step 2. It's going to be get formula. Hireability. Oh shit, what did I press? Okay, so there's hireability is the first argument, and the second argument is reduction step 2 feature names. I think I'm supposed to be using double quotes for string. Okay, so here is the actual reduction step 2 model, and then I want that model summary. Okay. Boom. How did you get your job? So my current job, which is at a big N company, I got through tech systems. So don't sleep on recruiters. What language is this? This is Python. I'm using scikit-learn, stats model, and some stuff like that, but the language is Python. This is not my job, though. Like what I'm doing right now, this is not my job. So yeah, ask more questions if you want. But how did I learn Python? I taught myself. So I learned statistics through my PhD in economics, and they primarily relied on the programming language Stata. Stata is not open source. You know, I like open source, so I taught myself Python, and I do not regret going back. Python is like the bee's knees. Big fan of Python for data analysis. I don't recommend it as a first programming language unless you want to get into data analysis. So caveat there. Okay, so OLS object has no attribute summary. Right, so I need to fit it and then get the summary. Okay, so here is the reduction step model 2. Let's just re-verify there should be no p-values at or over 0.5. We see that is the case, and they go as high as 4.9, so it's not like we are over-restricting. It's doing exactly what I want. Okay, so we got the r squared of 9.8. We got an adjusted r squared of 9.0. AIC is 77, or let's not round it, 77.56. The N is 86 still, and the K is down to 67, which is great. So we've accomplished our goal of improving the model according to adjusted R squared and AIC. And we also increased the degrees of freedom because we reduced the number of independent factors. And we did not even change the R squared from a rounding error. So it's still 9898. It might have been like 98 something. Is this a machine learning model? It depends who you talk to. How do you define machine learning? So this is statistics. But yeah, some people would say this counts as machine learning. I mean, it does. Here's the thing: like, what is the machine learning? I'm giving it. Yeah, it counts as machine learning. It's just machine learning is really stupid because the definition's too broad. There's no intelligence here. It's just running a really complicated algorithm. It's basically a glorified function. It's not thinking on its own. But anyway, some people would still call it machine learning, yes. Thanks for the likes, 948 likes. That's really awesome. Okay, so we've got step 2. Now what we want is step 3. So reduction step 3 model equals so here's reduction step 3 feature names is equal to reduction step 2 feature names plus LOOCV underscore WX unique features. And so let's add a note is identified by analysis 5 Cool. So there is reduction step 1. There is reduction step 2. Yeah, this is actually not correct. Should be COVID remote should be these. Okay, cool. So LOO, it's basically this. Bro, Bro is just editing comments. Yup, that's all I'm doing. All right, so here are the unique features. We need to append this into the formula. So here's the reduction step 2 model. Okay, so I already said reduction step 3 feature names. Here's reduction step 3 feature names. This is not right. So this would be, I guess, what are we calling step 3? So this would be like the pool that 3 is going to be selected from. Okay, that can be step 3. Let me write that down. Steps. 1 is analysis for result. 2 is backwards feature elimination on 1. 3 is analysis 5 result plus 2. 4 is BFE on 3. Okay, so these are the steps. Now the question is, can I afford to do more than that? But we'll stick with that. So how many is this? I have 80. I have 18 I can fit in. Yeah, I think this is about all I can do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Actually, I might not even be able to do these. That feels bad. Okay, so COVID remote. COVID remote, no increase or decrease. Okay. So here's COVID remote slight degree. Needs to be underscore education, underscore energy, underscore law, manufacturing, military, right? Yep, retail, transportation, Gonna do that again right down there. Retail again right down there. Military again right down there. Okay, so those factor names are updated. This one is spelled wrong. It's conservative or evangelical Christian. So that'd be conservative or evangelical Christian. Okay. Cool. So I think they're spelled right. I think it's too many factors though. Okay, so here are the unique feature unique feature names. Unique features, unique feature names. Okay. This is really not good. So I need to put this into conclusions, like better, how to make it better. A better analysis, here's like a better analysis could use the R squared maximizing elastic nets without need for stepwise refinement. Would require sample about 500. No, maybe 400. What are you doing? So I'm trying to understand gender effects in the tech labor market. So like, why are there so few female programmers? So this would be the step 4 feature names, the way I redefine the steps. Step 4 is BFE on 3, right? So here's the BFE, backwards feature elimination. BFE on 3, feature names would want to go like this. So step 3 feature names is the result of some model. So here is the step 2 model. Here's the step 2 feature names. And we want to get formula, let's see. So this would be the step 3 model. Step 3 model is step 3 model. So here's the reduction step 2 formula. Reduction step 2 formula yields the reduction step 2 model. So let's get the formula and the model for step 3. So reduction step 3 formula, reduction step 3 model. And then this would be the feature names. So there's 3 feature names, and that gives us 4 finally. Okay, so the issue here is that this snippet is not correct. So here's the step 3 formula. And can we just do, the question is, can we just do the step 2 formula plus these? Let's see. And then we're going to want to print it, I think. Print. So then we're going to want to step 4 formula, step 4 model, and we're going to actually want to print the step 4 model summary. So this would be the feature names for 4. Here's the formula for 4. Cool. So I'm basically not reading 3 because I really don't care about it. But we'll see if this breaks. Yeah, see it breaks. You see infinity, 0, non, non, non. Because there's not any degrees of freedom. You see that? So I have too many variables. What's this code for? Hey, so this is Python. We're doing regression analysis. So I'm writing a research paper on gender equity and coding boot camps. So that's what this is for. So let's do this real quick. So this should pass. It's just not what we want, but this is just to prove that the code is technically working. Yeah, so see that worked. So there's some different things that I could do to address this. One is I could shrink my net, so I wouldn't get 81. I would instead maybe go down to like 57. Right? So there's an easy way to cut 20 variables. And then we would be able to fit through this hoop, right? I don't know if I like that though, because I want all the variables. So the problem is that not enough of these variables are being cut, yeah? Okay. So the second idea that I was thinking of is I could do more steps. So if I do more steps, the idea would be that I break this into 2 steps and that it'll shrink enough that I can get through. Yep, let's try that. So I'm going to try to push I'm going to separate the gender effects and do those all at once. Note, if this works, why not increase NX elastic net? Okay, so this is the gender effects, and this will be no gender effects. Okay, you can see gender male, gender male, gender male, get rid of all those. Gender male. So you see now the step is smaller, basically. There's fewer factors to consider. And the idea will be that not all of these will survive. And so then we will be able to, oh, ever wish you had VS Code during your undergrad? Oh, what's up, Lewis? Yeah, I'm having a good day. It's my birthday, actually. Appreciate the likes, 948. That's pretty good. So do I wish I had VS Code during my undergrad? I don't know. Like, I didn't do programming in undergrad. So I guess one way to rephrase the question is, do I wish I did programming in undergrad? And still the answer is I don't know, because I took a couple courses of programming in school and it was really poorly taught. So I have a really bad feeling about programming in our education system. So on the other hand, I don't know. I'm very mixed. On the other hand, I did stats in Excel. It wasn't that bad. It got the point across. Host invites you to go live. Okay. It's Baby Colton. Sure. What's up? What's up?
You're about to hack us.
Huh?
Are you about to hack us?
Nah, dude, nah.
Are you about to tell us where we live?
Oh, you're on the East Coast.
No. I'm from them.
Okay. I was just guessing. I can't hack. Actually, I can hack, but that's not what I'm doing right now. Why do you want to hack people? That's mean. Hacking is mean.
Yeah, well, guess what? You're doing it. Look at you. What are you doing?
I'm trying to do research. What you know about that?
You're not a damn thing.
Do you got Microsoft Excel? You got some You got some spreadsheets going on over there?
I don't know what that means.
Do you play? Yeah, okay, they're bound. They're pieced out. That's pretty hilarious. How would you explain Microsoft Excel to somebody that doesn't know what it is? It's like spreadsheets, right? So here we took out the gender effects. Here we're only looking at the gender effects. So I'll remove this one. All of these, we can get rid of these. Bam. And this one. Okay. So we're changing the steps. Let's go write it down. So BFE on 1, analysis. This would be the non-gender results. Plus 3, BFE on 3. 5, 6. This would be BFE on 1. Okay, so analysis 4, BFE on that. Then the non-gender effects are what we test, and then we BFE on that. And then the gender effects, and then BFE on 5. Cool. Harvey Dangerfield. That's a cool name. Oh, somebody asked a question. What is this? Asked, what are you coding? Oh, I think I already answered this, but I'll answer it again. So this is ordinary least squares, statistical regression, written in Python programming language to investigate coefficients, that is effects, in hiring decisions. And specifically, how does gender play in? So it may turn out that gender is insignificant and that it has very little to do with gender, but I think I'm sus on that. How about you? All right, so we'll move that step down there. So now what we got is no gender effects. All right, so let's print this step 4. Feature name is not defined, okay? Did I not save again? Dang, I just didn't press Control S. Did you grab the data set from Kaggle? Nah. This is original data that I collected myself. So check this out. This is a playlist on YouTube. You can just go my name, John Vandeveer. That's my YouTube channel. Check it out, sub it, like it, whatever. By the way, if you're watching this on TikTok, it's kind of hard to see the screen, right? So if you go, like I'm live streaming to YouTube too, and you can see the whole screen better. anyway, here's my YouTube channel, John Vandeveer, and I have this playlist, which is Digital Bootcamps and Gender Equity. Hours and hours and hours. Like, are we up to 24 hours yet? We're well over 12 hours. In the first few, I show you how I collect my data set. So I use Amazon Mechanical Turk to recruit survey participants. And then the survey, they take a survey on SurveyMonkey. So that's how I get my data. It's my own data. What are we learning today? Life of Ballsy. Thanks for the question. Doing research on the tech industry and why are there so few women, basically. Is there anything we can learn or do to increase diversity, gender diversity specifically? Although I got to tell you, once I'm done getting this research, it's probably going to lend itself to further analysis for other measures of diversity, like ethnic diversity and ideological diversity. A lot of people, you see, I got a factor here for religiosity, and people are like, it freaks people out to talk about that stuff, but gender is important, ethnicity is important, and ideology is pretty important. It turns out it relates to decision making pretty strongly. Okay. So this worked, right? This worked. I'll run it one more time just so y'all can see it, but basically that worked. Okay. DF model is 70, so we still got 15 degrees of freedom. So here we are. This is reduction step 4. 4 is the BFE on 3. That's right. So we just finished a BFE, and that's where I'm recording these notes. Let's see. Reduction step 2, I put it right above the formula. So let's do it right above the formula. So little line explaining what it is. NX elastic net before cutting by p-values. Nope, this is after. So step 2 is after cutting by p-values. Okay, and so this would be the NX elastic net plus WX elastic net gender effects after cutting p-values. Okay. Ideological is so important and keeps being overlooked. Yeah, for sure. Spoiler alert, you have to remove interview bias. Hey, so the bad news is, even if you remove interview bias, there's a lot of bias left. So it turns out that like a lot of biases in the system before anyone even gets to looking at the resumes. Forget like you have an interview, right? But before your interview, you have a resume that has to go through an ATS. There's a bunch of ATS in the interview. There's a bunch of bias in the ATS. But before you even have the ATS, you need a resume, which means you need to put stuff on your resume. And what goes on your resume? Your education and your experience. So there's bias even in those. So just hire whoever is taller. That would be, I would actually be really curious about hiring whoever is taller, because like it might be about as good as what we're doing today anyway. Like, what data cleaning methods did you use? So check out this, everything here is open source. Let me show you the repository. So obviously here are the playlists. I go through data cleaning in the playlists. But I also have the repository itself, and you can inspect the code. So this is my last name, Vandeveer. It's a pain to spell, I know. I was born with it. But here is the like folder where all my data and analysis is. So the data cleaning, and I call it wrangling, by the way, right? Because wrangling includes more than cleaning. Wrangling includes cleaning as well as just reshaping and renaming variables. So cleaning implies that there's like some error, some dirt in the data. Wrangling is cleaning, but it's also reshaping and it's also engineering features as well. And I do all of that in this analysis one variables and regression file, which really should just be called analysis one variable definitions. You know what? Let me rename it right now. Variable. I'm just going to call it the Wrangler. Like jeans, you know. So all this code is open source. You can see how I did it. I start out by just like reading the raw CSV file. I replace some strings with numbers. I shorten a bunch of strings into like really small variable names to make it easy to work with. This is just like renaming things. Here's an example of wrangling, which is not cleaning because there's no dirt in the data. It's just making it into a variable that I can use, which is I take this one variable and I split it by comma, and it ends up producing 5 variables, right? I numerize a bunch of strings, and here's like some feature engineering. Computing skill gaps is like more feature engineering. So I do that all here. In terms of cleaning, I do compute a fraud flag. So there's a couple people who respond like they just go like 1, 1, 1, 1, 1, like all the way across the board. It's like that's sus. And statistically, if you drop them, you can see the improvements to data normality and predictability. So it's pretty clear that they're just like adding unhelpful noise to the data. I even say if sus skill value. So computing a fraud flag is one thing I do. And then another way of cleaning I do is I deskew. So I drop if people identified with other gender, because I only had 2 responses like that. So I can't really do statistics like that, right? So this obviously constrains my analysis, so that my analysis now only holds for males and females instead of all Americans. But that's like a caveat that I'm willing to make because it still applies to the vast majority of Americans. It still explains most of what's going on in the economy. And I can actually do statistics now, where I can't really do statistics with 2 responses. So that's some of the cleaning that I do. Here I'm converting categoricals to dummies. Oh, I got a follow. Thank you so much. Who is that? JLI Choose Love. Bet, choose love. 950 likes. That's amazing. Thanks so much for the likes. Tubero, thank you. Thanks for the follow. Okay, so where were we? So we were over here. Step 4 is the NX elastic net with effects. Yeah. Plus WX gender effects after cutting by p-values. All right, so we want to run this and get the no model named. Yeah. Oh, I need to go in and rename them now that I did that. That's probably why I didn't rename it previously. So I need to go in and like change the name to variable wrangler in all of these. Boo. Did y'all know it's my birthday today? I'm not kidding. Here is variable wrangler, 5 variable wrangler, 4 variable wrangler, 3 variable wrangler, 2 variable wrangler, and 1 itself is the wrangler, so I don't need to do that. Okay. So now this should run. Yay. Cool. So the r squared is 9, so our r squared went up. And the adjusted r squared is 9, 4. And the AIC is 33.39, N 86, K 70. Cool, so that was a boost to the model for sure. So let's do a commit here. This will be feat rename variable wrangler and reduction step 4 model. Sandman, what's up? What's up? Thanks for joining. Clickbait Cowboy in the house. Y'all got some cool names. Hey, so quick plug, if you've recently joined, feel free to check me out on YouTube. You'll be able to see my whole screen, right? So if you're watching on TikTok, you can't really see my whole screen. But here on YouTube, you can see, like, I'm live right now, and you can see the whole screen, and you can see my face. So, also streaming to Twitch and Twitter as well. All right, cool. So we got the reduction step for formula model summary, printed that out. Now we want to go to step 5, which is these guys right here. So this would be reduction step 5 formula, basically. So reduction step 5 formula is we're going to get formula with the feature names. Oh, I can just say it's the reduction. It's just the it's the step 4 formula. Can I do that previously? Oh yeah, so it's the step 2 formula. So it's the step 2 formula with new stuff. Then you get the model. Then you get those feature names. Okay. So here, the step 4 formula plus the gender effects. Okay. So here's the step 4 formula. And I want to have the gender effects now. Gender, yeah. Why does it just say gender question mark? Like, yeah, like male, female, other, non-binary, whatever, that kind of stuff. Those are genders, right? So did you know that, like, there are more guys that program than girls? So that's what we mean by gender effects. And the question is, like, why though? Okay, so there's the step 4 model. Here's the step 5 formula, and now we want the step 5 model. Python is for women. You gotta love TikTok, don't you? Jeez. Okay, so here is the formula. So now we have the model, and then we can get the exogenous factor names. That will be the step 6 feature names. Okay, so step ooh, something's funky here. So step 4, yeah, that is this is the step 5. This is the step 5 model feature names. Step 5 feature names. Okay, so we got 1, 2, formula, model, feature names, 3, 3, 3. Yep. And then now we have 4. 3, 3, 3, 4, 4, 4. So we got, that's right, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, boom, boom. And now this will be 6. Cool. And 6 works by taking in 5 and reducing it. So 4 works by taking in 3 and reducing it. And 6 works by taking in 5 and reducing it. Then I'm a woman, so be it. That's awesome. Are you doing like linear regression models to figure gender stuff? Yeah, basically. I'm not just doing linear models, but currently I'm doing linear models. Yeah, so model OLS, that's a linear model for sure. You could say that it's a curvilinear model. Here's a fun word, curvilinear model. Because I have like familiarity count squared. So that's an exponent, right? So it's not a linear relation. That we call that a curvilinear relation, where you put a nonlinear factor into a linear model. But it's this file that I'm working on currently is basically still using linear regression. Yeah. Okay. Anyways, so we have step 5, backward elimination. Then we get step 6, feature names. Then we want the step 6 model. I guess we want the formula, then the model. So here's step 6 feature names, get formula. Now we have the step 6 formula. And then plug the formula into stats model. And now we have the step 6 model. Now we can summarize the model and get some data. Show me that data, baby. Hey, girl, where your data at? Cool. So this is kind of like my boilerplate for notes. And run that Python. Daniel followed the host. Appreciate it, Daniel. Oh, I'm pretty sure I'm over 2100 now. I have to go make a 21 Savage video. 21. Okay, so these are not, they're not destroyed, so we survived. We survived the step. If this broke my model because there's like too many variables, it would be like infinity, -0, 1. So that's not happening. So our model survived. Look at this, 995. So it rounds to 1.0. Like, we've been rounding it, so for consistency, we got to round it to 1.0. Adjusted R square is 9.6. AIC is -24.37, which is really good. Are you going to put it into a visual graph? There's going to be some visual graphs in my research paper. I don't know. I don't think I'm going to put this into a visual graph. I might put it into a table, maybe, just like a table of regressions. But even that, it's kind of like, do people actually care about all this shit, or do they just want the results? You know, whenever you're writing a research paper, this code's available, the data's available, they can go check it out. But like, do they really want to read about this? Like, they probably just want to read the results. You know what I mean? That's always like a hard thing to balance though. Like what specifically do you talk about versus what do you cram in the appendix and what do you just like not? Okay, so we got 1.0, 96, got the AIC and the K of 73. Cool. What are you doing, sir? And what is this project? So we are doing research on the tech industry. So why are there so few female programmers? Hey, did you know? Let me actually read the opening line to my research paper. I think that'll help. So this is a tech file. LaTeX is what we use to generate the PDFs that show up in journal articles. So the paper is called Coding Bootcamps and Gender Equity. And during the introduction, I say, this paper provides a review of the current knowledge and original empirical evidence to solve for the present gendered debt crisis. So there's like a debt crisis in America. Did you all know this? Look how much debt, freaking student debt in America. It's insane. $1.5 trillion. $1.5 trillion. 40 grand a person. It's so much debt. Can you all see this? There's so much student debt in the United States. So how do we get rid of that student debt? Now, the other thing about this student debt is that it's not even between men and women. 60% of college students are female. It is no surprise that about 60% of student debt is held by women. So the debt crisis is a huge problem, and it's actually an even bigger problem than women. Not only do they hold more of the debt, the problem of debt payoff is a harder task for the average woman because the average female has lower earnings than the average male, right? So this is like a really shit situation for women. And imagine that you're heartless enough to go, oh, well, they decided to go to college and like they decided to have all this, debt and they decided to have lower earnings. Okay, I think that's savage enough. But if you're savage enough to say this, they certainly did not pick to be disproportionately impacted by the coronavirus pandemic, right? So that the coronavirus pandemic had a gender effect, pushed the female labor force participation to a 33-year low. So, like, if you think all this progress that was made in gender equity, all this progress that was made in the 90s and the 2000s, like, we're back to the 80s, dog. Like, thanks, coronavirus. We're back to the 80s. Like, I was born in 89. I'll just give it away. It's my birthday today. So we're back to before I was born. Like, that's how bad it is in terms of the labor force participation rate, which impacts the ability to earn, which impacts the ability to pay off debt. Are you seeing the problem here? And then, so like, how do we solve this problem? I say here, I'll read that piece too. 2 naive solutions to the gender debt crisis include 1, increase earnings for women, and 2, reduce the college debt obtained by women. This paper will argue that these naive solutions are exactly appropriate. Okay? So basically, let's let women earn more money. How? That's a big topic. That's what this paper is about. The other thing we can do, let's reduce the college debt obtained by women. How? That's a big topic. That's what this paper is about. Basically, the answer that I suggest is coding bootcamps. Coding bootcamps have way less debt. Coding bootcamps, when you graduate, your earnings capacity is through the freaking roof. So the question becomes, why are women not using coding bootcamps? Oh, fun fact, actually they are. So CS programs are 20% female. Coding bootcamps are 40% female. Well, you wonder why. Maybe because it's a great deal. Hello, that's one reason. But that still doesn't quite explain the whole thing away because in college, 60% of college enrollees are female, but only 20% are in the CS programs. So it's not like a 50-50. So when we go from 20 to 40, and then you go, oh, 40 is pretty close to 50. You didn't quite explain the whole thing because you're only like 2/3 of the explanation there. Does that make sense? I don't think I said that very well. I'll have to think about how to explain that better. Anyway, So we got this R squared, we got the adjusted R squared, we got the AIC, we got sample size of 86, and then K 73. Yeah. Cool. I got it. Thanks. Yeah, I appreciate that. Hey, if you think this is cool info, give me a follow, give me a like. I don't know if y'all know this. If you like the live stream, that's how TikTok pushes it out to like other people. All right, so what did we do just now? We made model 6, basically. That's what we did. So now, so this is the elastic net with gender effects. Okay, so this is so we've gotten through the whole elastic net by now. So now I want to add the SFS, okay? Okay, so BFE on 5, now we got to 6, we're on 6. So the next step is so we got 2, 4, and then this should be 6 plus SFS gender effects. And then that will be BFE on 7. That'll be step 8. And this will be the preferred model. Okay? Should I reduce further from here? So maybe I do another reduction after step 8, but we're at least going to step 8. Okay, so now we're on step 6, and what I want is step 7. Okay. And then this will be step 8. Okay, we don't need that. This is going to be 8. So 5 is the 4 formula with new stuff. So 7 is the 6 formula with new stuff. What is the new stuff? This would be the SFS unique feature names. Okay, SFS unique feature names is hello, where'd you go? Here it is. SFS unique feature names. This is the SFS unique feature names. I need to format these variables a little bit. Okay. So this will be before step 7. Cool. And this is identified by analysis 6 SFSCV. NPM run. That's top tier, dude. NPM run. Are you using a machine learning model? I mean, fuck it. Let's say yes. So this is actually statistics But I use scikit-learn. It depends who you talk to. What does machine learning even mean? But some people would consider this machine learning, yes. I'm using the elastic net out of scikit-learn, so you can call that machine learning. Fuck it, sure. This is really like way bigger than machine learning though. The thing that annoys me is when people do machine learning and they don't know what they're doing. It's like a black box or a closed box. Unsupervised. Ooh, unsupervised is cool. Actually, unsupervised means you don't know what you're doing. So this is semi-supervised. Actually, I would argue that this is wholly supervised. This is, so if, yeah, you can call it supervised machine learning. How about that? Arguably supervised machine learning. I'm doing machine learning this semester and I have no idea what's going on. Hey, all you need to know for machine learning is gradient descent. If you know gradient descent, you know machine learning. Everything else is just a bunch of different terms for different ways to use gradient descent. Which is why, by the way, I really resist calling this stuff machine learning because I'm not using gradient descent. Anyways, that's how I think about it, but your professor probably has a different definition, so go ask him or her. All right, so here's model 6. Great, great, great. Sexy fucking sexy, unique feature names. Cool. So now we have the 7 formula. Plug the 7 formula in. Now we have the 7 model. Grab all the exogenous variable names from the 7 model. Now we have the 7 feature names. Plug the 7 feature names in. Do a backwards elimination. Is that machine learning? I don't know. I'm just some dude. It depends who you talk to. This backwards elimination method. So you could consider it supervised machine learning if you want. It depends on what your definition of machine learning is. You could call it supervised machine learning, or you could call it an econometric statistical algorithm, a theoretically driven econometric statistical algorithm. Okay, so anyway, we run a backwards elimination. Now we got the reduced feature names, and let's turn that into a whole formula, and let's turn that into a whole model, and let's fit the model. So now we got model 8, baby. Roll it. Royce Cotton joined. What's up, Royce? Oh no, we broke. Oh, invalid syntax. Okay, I'm fine with that. So I need to rewrite these variable names. I forgot about that. Okay, so T energy is just going to be energy. Law goes to law. We just have to do this every time. Military. Real estate. Transportation. Real estate. Real estate, real estate. What else do we got? Any of these brackets I need to rename. Okay, here's retail. Retail. A retail. Industry retail. Manufacturing. Retail. Retail. Okay. Joe Crowley. Awesome. Bam. Will it blend? Son of a bitch, I'm out of coffee. Oh, we hit some collinearity patches. Do we have any degrees of freedom? We still have some degrees of freedom. It looks like a partial collinearity problem. Look at that. You see the NANs? That's bad. But my whole model didn't blow up. If my whole model blew up, it would be NANs all the way across the board. So this is only NANs with some of these variables. So there's only a partial collinearity problem. Which means I should be able to drop those. What is collinearity? Collinearity means that there's another variable that contains the same information. So what I'm going to start by doing is dropping the industry caveat. So the industry is elsewhere represented. We can see that, right? So this is health. Yeah, so I'm going to try dropping, and then if I drop that, what am I left with? I'm left with this. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many industries are there in my survey? Okay, pull up a copy of my survey. Because if all the industries are there, that's the problem. Does that make sense? That would be perfect collinearity because you got to drop one of them. I'm going to try just dropping one of them instead of like dropping all of them at once. But let me look at my survey first. Figures and tape note, preprint submission packages. Here's the questionnaire. Okay, industry. Here's the question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's only 12, and I only counted 11 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I counted 10. Okay, so the problem should not be perfect collinearity from a theoretical point of view, but it's still perfect collinearity. And it still might be practical perfect collinearity. What's the difference between theoretical perfect collinearity and practical collinearity? Theoretical collinearity is you combine all of these, there's no longer any variation. Like everyone falls into one of these buckets. So you have to drop one, and I dropped agriculture, you may remember. If we go back to the Wrangler, I dropped industry, agriculture, you see? So I never bothered to check, did anyone, so here's where the practical collinearity comes in. Did anyone even pick agriculture? If no one picked agriculture, I didn't actually reduce the perfect collinearity problem. So it could be the case that even though there are 12 options, plus there's the other category, it could be the case that even though there are 12 options, like only 9 of them were ever picked. Or I guess since there are 10 here, only these 10 were ever picked is possible. And so if only these 10 were ever picked, if I don't drop one of these 10, we have the collinearity problem all over again. So a quick test I can do here is look at my raw data. And I'll get to your question. I see the question, Sandy. I'll get to that in one question. But let me check my raw data. And the question is, did anyone actually pick agriculture? Yes, they did. Yes, they did. Okay. So this is good and bad. What this means is it's good in the sense that there is not a problem with my industry variables. That's good. What it means is that we only run into perfect collinearity in the context of this multiple regression, not in a general context of the way I've constructed my variable. So what that means is all these other questions, that people are answering, they're also some yes or no questions, like gender male. So that if you do a cross section of these things, you're still getting a perfect multicollinearity problem in these buckets in the context of this multiple regression, not like all the time with industry. Does that make sense? So for example, if I went back to my raw data, somebody picked agriculture, but what if I filtered out all the women so that only men were left? Maybe now no one did pick agriculture. And if I filter by all the other variables in this regression, what I'm going to find is that there's no variation left. There's no variation left for these factors to compute a coefficient. That's why they're 0. And that's why it says not a number. Okay, I'll solve that problem in a minute. But to answer Sandy's question, what you coding? This is a research paper. So this is all open source. The data is open source. The code's open source. The paper's open source. Here's the title, Coding Bootcamps and Gender Equity. So coding bootcamps are extremely helpful for anyone, regardless of gender, in terms of increasing their ability to earn, and they're a great return on investment. So if you think about the return on investment to education, and if you compare a coding bootcamp with the typical college degree, coding bootcamp beats the snot out of it. So now let's talk about this other problem. There's a student debt crisis in the United States, and it has a gender component. So women hold most of the debt, and they have reduced capacity to pay on average. So it's a really big problem for women specifically. It's a problem for all Americans, but it's a really big problem for women specifically. So one possible solution to that debt crisis that disproportionately benefits women, if we can solve it, is using coding bootcamps. So there's two questions here. One is, how do we increase the use of bootcamps in general? And the second is, how do we increase the attractiveness of bootcamps to women specifically? So that's what this paper is about. Hey, thanks for the follows. I appreciate that. If you liked it, and if you followed me, I bet you liked it, consider tapping the screen, giving some likes to this. When the TikTok gets likes, that's how, like when the stream gets likes, that's how TikTok knows to send it out to other people. Thank you so much for the follows and the likes. How long have we been going on the stream? Wow, I just crossed the 4-hour mark on this stream. That's wild. I'm loving it. Hey, thank you so much for those likes. Oh, we broke 1,000. Hey, broke 1,000 likes. Bet. I'm here for it. Okay, so let's get back to doing some codes, huh? Okay, so we broke here. There's a perfect collinearity problem. And this is where it gets tricky as a researcher, because there is a way to fix this. And the way is that I have to arbitrarily drop variables, which is like super awkward. So I'm going to make a note of this. This is definitely something you would want to note in your results section of your paper. This is like a caveat. Like I had to arbitrarily drop. It might go in results, it might go in methodology, but I'm going to put it in results for now. So note, I had to arbitrarily drop from reduction step model 8 to remove perfect multicollinearity within this group. And I'm going to list them. So this is the group. I don't need all that. So also we can remove this one. Boop. So this is the problem group. And we can get rid of all these. Clean that all up. Okay, so this is the problem group. I had to arbitrarily drop. And so which one am I going to pick? Well, I'm just going to pick the top one. Arbitrary is arbitrary. In the energy industry, there's nothing interesting about it to me. It has nothing to do with this paper, so I feel fully content just dropping that bad boy. Can you edit? Can you name anime character for an edit? I mean, anyone can name Naruto. Anyone can name Ash. I like the one that I like though is Full Metal Alchemist. What's that guy's name? He's the Full Metal Alchemist, but I can't remember his actual name. Full Metal Alchemist real name. Can y'all help me out here? Do y'all know what's the Full Metal Alchemist's real name? Help me out. Is this TikTok or not? Full Metal Alchemist character, like main character name. Edward Elric. There you go. Edward Elric. Sweet. Okay. Yeah, I really dig that show, to be honest with you. What do y'all like to watch? Okay, so here's going to be arbitrarily restricted. Now, the other thing I could do is I could drop all of them. And I may end up needing to do that. If they're perfectly multicollinear, I may need to drop all of them, which in a way is less arbitrary, right? It's like at least it's a fair treatment. You're dropping all of them. But I'm going to test not doing that. And then I'll do that if I have to. So this is arbitrarily restricted. Okay, so the first one is industry energy. That's the top collinear one, yeah? There's nothing before that. Later energy industry, bye. Does it gain me a lot or a little? Python, tell me, Magic Python. Um, 1, 2, 3, 4, 5, 6, 7, 8. So it didn't gain me much. We previously had 10, and I dropped 1, which makes 9. And now I still have 8 that are perfectly collinear. So it gained me 1 variation. It literally gave me 1 variation. And I bet I know where it is too. So you see here's energy industry, energy industry, energy industry. I bet it saved me on the next energy industry. So favor seeking risk. Energy industry. Whoa, whoa, whoa. 1, 2. No. 1, 2, 3. 1, 2. Weird. I don't know how that happened. All right. Well, we will just start dropping them kind of one at a time. I'm going to drop the industry all the way through. So next, let's drop this. One, two. So like, how many lines did I just highlight? So energy industry is still collinear, so let's drop that one next. Okay, so let's just do a quick pause here. And what have I lost and gained? So 239 minus 221. So there's 18 variables here, right? Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Uh-oh. Did I math bad? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yep, no, I know what I did. It's you have to add one back. So the difference is like one difference, two differences. Two differences, but three variables. So it should be 239 minus 221 plus 1. So it's 19. Okay, so we got 19 variables here compared to 217 minus 196 plus 1. So I've dropped 3 variables as expected, and they're specifically all energy variables. So I've dropped 3, and 1, 2, 3, 4, 5, 6 are still perfectly collinear, which would make a total of 9, but there was a total of 10. So I've only gained 1. I've lost 3 and I've gained 1. So this does not seem to be a case where dropping a few gives me a bunch of degrees back. It seems to be a case where I basically need to drop all of them. So we'll continue on that path, but it's going to get increasingly arbitrary as I have to pick like, I picked the energy industry and it was already arbitrary, but it was like defensible enough. It was like, okay, I picked the top one. Now I got to pick more. Okay, well, I just picked all the industry variables for energy. But now it's like why real estate? That feels so weird. I think I just need to drop all of them. So at this point, just for theoretical reasons, I'm going to drop all of these collinear variables. Okay, so what are you doing? This is statistical research. So thanks for asking. So this is Python programming language. So follow my page if you want to learn to code. Something to do with money. Kind of. It's more like hiring. So I'm trying to do a regression of hireability. But yeah, it's related to like student debt. It's like people go to college and they have to pay a bunch of money for college, right? And they get this huge student debt. Yeah, for sure. So how can we reduce all of the student debt for college? Well, one thing is that you can do an alternative learning, like a boot camp, instead of college. That's like an easy way to reduce your debt. So like, why don't more people use those boot camps? Like, that's the question that I'm researching. Specifically, women. Why don't more women use those boot camps so that we can get more diversity in the tech industry? Okay, cool. So we are just going to drop all of the collinear ones. SFS unique feature names. Collinear dropped. So in a way, this is nice because it's like less arbitrary. So instead of arbitrarily restricted, we're going to do collinear drops. So it should be these 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's only 9. I thought it was 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Cool. So let's run this again. This is with the collinear variables. So I should see 9 zeros with a p-value of not a number. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So those are they. And industry, energy to real estate. Industry, energy to real estate. So those are they. So these are the ones that I need to remove. Cool. So here are all the ones, including the ones that I should remove. And now let's remove Let's remove the ones that I should remove. All right, there goes energy, industry, law, and real estate. So really all three of these: energy, industry, energy, industry, law, and real estate. Bam. All right, all gone. I'm gonna just try this just out of like guessing, basically. I think I still need to drop more, but I'm gonna try to minimize what I drop. 1, 2, 3, 4, 5, 6. Yep, no, still gotta drop them. Feels bad. Okay, so energy, industry, law, and real estate once again. So energy, industry, law, and real estate. Okay. Let's do it one more time. Should have 3 more that it's going to make me drop. Feels so bad. Would it be better just to rim them out in case you need them in the future? What do you mean rim them out? Rim them out. Energy, law, real estate. Energy. Cool, so now this should be collinear dropped. Also want to be sure that I'm spelling collinear correctly because I'm not sure that I am. All right, there we go. Does it have 2 L's? No, I spelled it correct. Oh. Can you spell it either way? Is it one of those words? Collinear. Yeah, you can spell it either way. I hate that. I hate it when there's 2 ways to spell the word. Rem comment so that you can comment them out. Yeah, I mean, I can track changes anyway. I'm using GitHub version control, and I can always recompute them if I ever need them again. Like, it's just the result of Formula 6 after backwards elimination. Oh no, this is actually the result of analysis 6 file. So I can always recompute it if I need it. So I'm saying collinearity with 2 L's. Am I saying collinearity with 1 L? Oh no, I spell it both ways. I'm the worst person ever. Multicollinearity has 2 L's, so it's going to be 1. We're gonna do it with 2 L's. All right, so this is going to be called collinear. Collinearity dropped. Okay, it's collinearity dropped. This is multicollinearity. And then collinear. Cool, so fix some spelling. Sorry, I can be pretty old school sometimes. Yeah, no problem. You're right, either way would work. I use remarks when I do changes. Hey, no problem with that. No problem with that. Okay. So now we have model 8, which is the reduction of model 7 after dropping some variables for perfect linearity. Okay. So what are our model factors? R squared rounds to 1.0. Adjusted R squared is 97. the AIC is negative 63.87, 86 observations, and 76 model degrees of freedom. Okay. I think that's dependent factors in the model. So this is model 8. So the question is, are there any gender variables here? And the answer is yes, a shitload. So it's almost like gender matters. Interesting that pure gender has a sort of a kind of a moderate effect there. It's not a really strong effect. What exactly are you working on? What are you modeling? So I'm working on a research paper. So this paper is called Coding Bootcamps in Gender Equity. The paper is open source, the data is open source, the code is open source. So what am I modeling? I'm modeling hireability. So the technical definition of hireability is, let's read it so that I don't screw it up from memory. Hireability is a non-price indicator of willingness to hire on the basis of an alternative credential. You love the clicky sound? Thank you so much. It's a vibe. Wow, 1.3 thousand likes. That's really great. Thank you all so much. Oh, and it's my birthday today. Okay, so I'm going to commit at this point so I don't lose my findings, and this will be, the feature is reduction step 8 model. Not much to research. I'm not sure what you mean, but okay. Comp sci major. Hey, what's up? What's up? See us in the house. Okay, so now we have this model. This is our preferred model. So what are we going to do with it? Code a YB app. I don't know what a YB app is. Cool. So we got this model. It's really, really great. It's probably a little overfit, honestly. Should we reduce this model further? So I think it's really interesting that a pure gender effect survives right here. But the gender interactions are also all over. An app of Lord Control. Oh golly, no thanks. Haven't used Python in years, mostly Java in all my classes, getting introduced to some C. Have fun. Are those correlation coefficients? Yes, indeed. Yes, indeed. What algorithm are you using? Yeah, there's no one algorithm. I'm using several algorithms. If your analysis is based on one algorithm, I'm rejecting your paper. So one algorithm I use is backward elimination. One algorithm I use is ordinary least squares. here, what are some other things that I do? I do leave one out cross-validation with elastic net. So elastic net is a really, really powerful tool. It's a hybrid of lasso and ridge regression. And I do it with cross-validation. You're using unsupervised or supervised. This is highly, highly supervised. I do not believe in unsupervised analysis. You can't do unsupervised analysis. You can make an unsupervised prediction, but that's not an analysis. You need to analyze it, you need to know why. And you can't know why with an unsupervised method. It's unexplainable. So this is highly supervised right here. So all of the variables I'm considering have a theoretical justification. Every technique that I'm using has a theoretical justification. I'm using a combination of predictive and inferential statistics. This is not purely predictive. So leave one out, cross-validation, elastic net, and then I do sequential feature selection. And for sequential feature selection, I use 4 different approaches. I use generic univariate selection twice with different modes, and I use vector regression twice. I use linear regression once and vector regression once. And I'm using different scoring, different optimization metrics in every case. What are you writing? Fellow developer here. Yeah, so this is research. This is Python code, specifically using like stats model and scikit-learn and pandas. And I'm writing a research paper. And then here's a LaTeX file, which is more like, technically it's, technically programming language, but it's really more like the old school Microsoft Word. How much data are you working with? Only about 100 samples. So this is not what I would call big data. I'm assuming you're doing a research over how gender ties into if you get hired or not. Exactly correct. Bingo, nailed it. Hey, Stormfang for the win. Jesus, that looks tedious. Yes, it is. Yes, it is. Yes, it is. Okay, so I have the preferred model right here, and I'm trying to decide what to do with it. By the way, only 3 states seem to matter. That's interesting. Tennessee for the win. Tennessee's a big thumbs up. New York is a small thumbs down. Pennsylvania is also a small thumbs down. Why don't you automate the process to set iteration amount? What iteration amount would that be? What number would you pick? The problem is that an arbitrary number is non-optimal. You need to have a boundary condition, not a number of iterations. And I do have a boundary condition. There it is, 0.5, which is my p-value. So I iterate until the p-value of all factors is under 0.5. And that has a theoretical, logical justification. That's not an arbitrary number. So this technically means, in statistical terms, this means if the p-value is less than 0.5, it means that logically, the expected value of the coefficient is more likely to be different from 0 than it is to be equal to 0. So that's a logical justification. Are you going to gather more data at a later point? That seems statistically insignificant. So it's not statistically insignificant. We have the metrics right here. R squared, adjusted R squared, AIC. Here's the F probability, which is like e to the minus, it's like 0. I mean your sample size. Yeah, hey, spicy ice cream. I don't think you understand how statistics works if you think you can reject significance on the basis of sample size alone. So all of these metrics that I just showed justify that these results are highly significant. So more observations would be great, but they would not be expected to change these coefficients substantially. Stormfang, yep. Yeah, I see that spicy ice cream thinks that. It's not true. Wow, 1.3 thousand likes. That's awesome, y'all. Okay, so what am I doing with this now that I have it? How so? What do you mean, how so? How is it so that it's not true that I need more samples? It's not true that I need more samples because I already have factor level metrics and model level metrics that confirm statistically significant and economically important results. And it's not just one model, but it's been reproduced across like 5 or 6 modes of analysis. So it's highly robust and it's theoretically consistent. And it's also consistent with prior findings in the economic literature. So like every box you can check is checked. What is the most impactful variable in terms of correlation? Well, yes, but only to a very small number of individuals. Hey, Stormfang, no, it's a small number of, it's a small sample. But the small sample doesn't mean that you can't generalize to a large population. So this sample is generalizable to United States adult Americans. Depends on how you gather your data and samples. Yep, totally does. This will be a good point to talk about this. So here is my YouTube channel. Go to John Vandeveer. If you watch it right now, I'm streaming live and you can see like the whole screen. You can see it better. But I have this playlist, Let's Code Digital Bootcamps and Gender Equity. So the video that I'm recording right now is part of this playlist. So we're on part 10. But if you look at parts 1 through 3, I go over the data collection and sampling approach. What's the conclusion? We don't have a conclusion yet. Good try. I mean, I guess there's this conclusion is that gender is significant, specifically these gender effects. Some more than others, like this one, meh. You can probably ignore transportation industry. But here in the information technology industry, look at that sucker, 004. So gender really matters, but yeah, trying to go from there to something useful. That's what I'm trying to think through right now. Let me look back at my paper. So the results section. Purpose of the current study is to detect gender effects, but only 2 observations of other gender were obtained, so they were dropped. Yep. Table to do shows dates of observation, sample sizes, mean hireability for 5 papers in the meta-analysis. Cool. I guess I should just like talk about the results and like don't make it more than it is or less than it is, right? All right, this is what I was, yeah, this is the part where I like needed to fix it because it was all fucked up. Okay, when categorical response options are treated as distinct dummy variables, the 94 question survey produces 165 variables. When the 4-way interaction plus related lower level interactions are counted, there are 246 variables. Okay, this is no longer correct actually. It's 143 variables. 143 variables. When the 4-way interaction plus related lower level interactions are counted, there are 246. No, there are not. There are 224. 224 variables. If the sample size is companies and not individuals, that'd be reasonable. I wonder why. Why do you think that? Any way to determine gender as the causality or a byproduct? I'm sure there are ways. I'm checking somewhat for causality, but not for a byproduct. I don't do anything with that. I coded a snowman in high school. Hell yeah, Mr. whatever. Jinko Anderson. Mr. Jinko Anderson. 1.4 thousand likes. Y'all rock. Thank you so much. If you want to learn to code, you can follow my TikTok, follow my YouTube or whatever. Okay, gender is important because it survives. Okay, so like, is gender even important is the first question. Well, it turns out, yeah, it is. Okay, so when categorical response options, okay. These variable pools were separately subjected to elastic net regularization with leave one out cross validation. Hell yeah, they were. Hell yeah, dude. Hell yeah. Male identification is the only gender variable in the pool of 143. In the pool of 143 variables, that excludes interactions. Okay? Male identification is the only gender variable in the pool of 143 variables that excludes interactions. Male identification is retained in a second best regularized model. Okay, so let's check on that. So here is the elastic net, and it is retained in a second best, but it's also retained in the best. It's retained in both. Okay. Male identification is retained in both a preferred model and also in the R squared maximizing model. I don't like the way this sounds. In the model that maximizes R squared. And there's a better way to write R squared. So I can use the LaTeX, yeah. Cool. Male identification is retained in both a preferred model and also in the model that maximizes R squared. Dark Villain, what's up, what's up? I only have a set amount of characters I can't explain well enough. Yeah, no, that's a whole vibe. Hey, you could make a little TikTok and tag me maybe. I totally understand though, like TikTok is not great for like deep technical conversations, right? It's like super annoying for that. Like, anyway. The preferred model concentrates explanatory power. Here, I should just spell out the metrics. That'll make it more intuitive why I picked that. The preferred model eliminates many features without important loss of explanatory power. Okay. Male identification is retained in both a preferred model and also in the model that maximizes R squared. Oh, and this is an out of sample R squared. Out of sample R squared. That's an important difference. Okay. Okay, when the Do I even need to say these, or can I just say it's retained in a preferred model? Okay, male identification is retained in the top 40% of factors ranked when. Oh, okay. When these factors are ranked for importance by their contribution to out of sample explanatory power, male identification. Really, I can say gender identification. Gender identification is retained in the top 40% of variables, and it is retained in the out of sample is retained in the out of sample is retained in the model that maximizes. Okay. And then I'll comment the fact that I prefer a different model. But I think that demonstrates at one level that gender identification is important. Gender identification is the only gender variable. Okay. Male identification is the only gender variable in the pool of 143 variables. That excludes, or which excludes? The 94 question survey produces 143 variables. These two pools, these variable pools, were separately subjected to elastic net regularization with lead-without cross-validation. Male identification is the only gender variable in the pool of 143 variables. Yeah. In the pool of in the pool of 224 variables, that includes the four-way gender interaction. That includes four-way gender interaction. In the pool of 224 variables, that includes four-way gender interaction, how many of the variables are gender variables? Gotta bounce. See ya. Just me for a joke. You coding? Yeah, I'm writing a research paper and there's a lot of code involved, but it's not just coding. It's also like writing, you know, it's both. In the pool of 224 variables, and the pool that includes, let me say it like this, and the pool that includes four-way gender interaction. I like the way I wrote it previously. When the variable pool that includes interactions is reduced, many gender interactive variables are retained in the preferred model. So I just need to update the numbers, and I like the way it was written though. So the lambda, that's not the lambda. So 005, so the prefer, yeah, so it's 0.09. And K is 48. And R squared is 7.1. Unknown file system error. What are you talking about, man? Unknown file system error. Get out of here. All right. Okay, cool. When the variable pool that includes interactions is reduced, many gender interactive variables are retained in the preferred model. What? Oh, it didn't save. How much did I lose? Balls. Lambda 1 over 2 is 0.9. R squared is 7.1. K is 48. K is 48. And if I hover, you can see the tech rendering. So lambda 1 over 2 is 0.9. K is 48. R squared is 0.71. This represents about 32%. Okay, from a pool of from a pool of 246 variables, 48. Variables are retained in this model. From a pool of 246 variables, 48 variables are retained in this model. No, it's not 246. It's 224. Bro, really hacking the Pentagon. What's up? What's up? What are you doing, bro? Writing a research paper. Writing a research paper about gender and the tech industry. When the variable pool includes interactions reduced, many gender interactive variables are retained. From a pool of 224 variables, 48 variables are retained in this model. This represents about what? So 48 over 224. What is that? This represents about 20%. This represents about 20% of the variable pool. 18 of the retained variables are gender related. Are they though? How many really are? 11. 11 of the retained variables are gender related. This confirms, oh, is that actually the majority? 24, no, it's not. It's about a quarter of them. This confirms the idea that interactive gender effects are more stable and important predictors of higher ability compared to a simple dummy variable. Right, so here gender was in the top 40%, and now gender is in the top 20%. So this approximately represents the top 20% of variables in the pool by importance. Eleven of these top 20. 11 of these important variables are gender related. This confirms the idea that interacting confirms the idea that interactive gender effects are more stable and important. See, I don't know about stable, but more important, yes, are more important. This confirms the idea that interactive gender effects are more important than gender alone. This confirms the idea that interactive gender effects are more important than gender alone. Yep, I really think so. Okay. So this preferred model doesn't perform well as the model. Nope, this is fake news now. That's changed. Second, heavily penalized, non-preferred. When the variable pool that includes interactions is reduced, many gender interactive variables are retained in the model that maximizes out of sample R squared. Okay, cool. Okay, no, this is interesting. This is interesting because we want to show that information industry is actually unique. So this is the preferred model, and this is a non-preferred model, but it identifies the single most important gender effect. And it happens to be related to the information technology industry. A second heavily penalized non-preferred model is identified is also interesting. A non-preferred model is also interesting. A heavily penalized non-preferred model is also interesting because it yeah, this is like a really complicated way of saying a whole bunch of shit that I don't need to say. Interesting, I'll just say this piece. Interestingly, the single most important gender effect using this approach is gender interacted with risk preference for a programming career, and occupation in the information technology industry. This aligns with the special relationship that has been observed between alternative education and the information technology industry. Sweet. That's a good one. All right, do I guard overfit by removing once identified variables, or do I try all of them? I tried all of them, that's fine. In addition to the elastic net, 4 kinds of the point of this exercise is to identify features robustly. To identify features in a way that is robust to multiple analytical approaches and multiple concepts of importance. So in addition to the elastic net, 4 kinds of, DS, data science, yeah? If DS means data science, we're hella in there. What language are you using? So this is LaTeX, which is like typesetting. It's like kind of like Microsoft Word, but in code. The analysis is written in Python, but I'm currently focused on writing the paper more than doing the analysis because I finished the model earlier. Yep, LaTeX, exactly right. Hey, Agnar knows what's up. What's up, what's up? Okay, so in addition to the elastic net, 4 kinds of sequential factor selection are tested to identify potentially important features. The point of this exercise is to identify features in a way that is robust to multiple analytical approaches and multiple concepts of importance. So let's go over here to the sequential feature selection. I could explain that different, like I could explain the 4 SFS in detail and the differing like modes of optimization. Yeah, I really should. Okay. Okay. Like, what's the point of a methodology if you're not going to say what you did? I guess the to-do is like to-do. I could put this in the explain this in the methodology instead of results. Twitch writes code. What do you mean? I mean, I'm on Twitch too. What up, CS Major here? Yeah, I bet. Can you make shaders? Nope, I don't know how to do that. Is this analysis based off EDA or have you used ML already? It's based off an EDA. So this is all open source, by the way. So analysis 2 is an exploratory data analysis. Boop, boop, boop. But I have arguably used machine learning. Like, it kind of depends what you mean by machine learning. I'm doing everything is heavily supervised because this is for theory. But it's all open source, so you can check right here. So Vanderveer, research dissertation case for alt ed. /tree/master papers alt ed gender. And then in the data folder, this is like where all my Python code and my data is. There's the requirements file too. Yeah, so there's the EDA. And then you can check out my YouTube channel. This is part of a series. So this is part 10, but you can see these other 9. All right, so what did the SFS uncover? I could also put this in a table instead of words. That might be better also. Okay, in addition to the elastic net, 4 kinds of sequential factor selection. Okay, two of the 4 SFS procedures use univariate selection. So one approach, it was to use the Benjamin-Hodge to estimate the false discovery. And accept features up to an allowed false discovery rate of 50%. Was it 50%? Yeah. Features were included up to an allowed false discovery rate of 50%. So the second one is family-wise error. Oh shit, I'm supposed to be getting on a call kind of soonish. I guess it's in an hour. The second univariate approach includes features The second univariate approach selects features by family-wise error. Selects features using selects features combinations of features that minimize the family-wise error. The second univariate approach selects combinations of features that minimize the family-wise error rate. Features were included up to a family-wise error rate of 50%. Okay, so then I also did vector. SFS using multiple regression. SFS, multiple and vector, multiple, okay. Multiple regression was also used. The other two SFS procedures involve multiple regression. And it's not just multiple regression, it's like sequential addition. The other two SFS procedures involve forward selection using multiple regression. Use forward selection of variables in a multiple regression. One approach is to follow and one approach is an ordinary least squares multiple regression that optimizes against median absolute error. Optimizing for mean squared error in both cases. Okay. One approach is an ordinary least squares multiple regression that optimizes for median absolute error. Optimizing for mean squared error was avoided to prevent the analysis preclude the linear analysis from becoming an extraneous subset of vector analysis. Oh man, I missed it. It almost looked like Justin Bieber's fanboy or something was calling. OLS optimization against mean squared error was avoided to preclude the linear analysis from becoming an extraneous subset of the vector analysis. The second approach is an ordinary least squares multiple regression that optimizes for median absolute error. The first approach is a multiple. SVR is what? Vector regression? SVR. Oops. SVR vector. Support vector regression. The first approach is a multiple support vector is a multiple support vector regression that optimizes for minimizes mean squared error. The first approach, the other two SFS procedures use forward selection of variables and a multiple regression. Yeah. So in both cases, feature forward selection continued until 56 variables are identified. This constitutes this is equivalent to taking the most important 25% of the total 224 until 56 variables were selected. Fifty-six. This is equivalent to taking the top 25% of variables. Collecting the preferred variables that were identified in any by any feature selection Dang, I didn't count them. I guess I can count them right now. So this is 104 minus 25 plus 1. inclusive of intercept. Big Lucky shared the video. Thank you so much. I appreciate that. Okay, so superset of all models count inclusive of intercept is going to be I can do this in like a couple lines. Plus. So there's non-gender. So there's this K, this K, this K. And so model 8K is 76. Okay, so 1, 2, 3, 4. So how many here? So the analysis 4 produces 81, right? Analysis 4 produces 81. Analysis 5 produces 48. But the 81 includes an intercept, right? Oh, so that's 81, and then non-gender effects. How many is that? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 81 plus 13, and then the gender effects were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, this is data science, y'all. So I'm doing a research paper. The programming language is Python, but I'm kind of done programming, and I'm more so writing the paper at this point. And so this is LaTeX. So the research question is on gender and information technology. Like, why are there so few women that program? And is there anything we can do about that to get more females programming? 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 of those. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. It's kind of one more time just to be safe. It's kind of backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. 22. All right, so that would equal, what is this? 126. Okay, but then we reduced it to 76. Okay, collecting the preferred variables that were identified by any feature selection process results in 126 how many did the straight ridge regression even identify? They're supposed to be at home cooking. Oof, oof, oof. Spicy. Collecting the preferred variables that were identified by any feature selection process results in 126 important features. Collecting the preferred variables that were identified by any feature selection process results in a count of 126 important features. Counting only those that were selected by all processes results in a count of 0 features. And picking some intermediary redundant count appears arbitrary. This is a model using all of these variables is both precluded by the sample size of the current survey, of the current study, and also expected to be overfit due to the fact that some of these selection methods do not account for collinearity. A preferred model is reduced. Okay. Poppy Sensei is back. Analyst, how to win the casino, please. Oh, sheesh. Nice keyboard, thanks. What am I watching right now? We're writing a research paper. Writing a research paper on gender effects in the tech industry specifically. I can shorten this to say 126 features are identified as important. In at least one of the 126 features are identified as important in at least one of the six by at least one of the six feature selection approaches. One hundred and 26 features are identified as important by at least one of the six feature selection approaches. The next important question. The next important result relates to the direction of the coefficients of these variables. Before those coefficients are identified, however, additional steps must be taken to eliminate overfitting. This is the not all, like several, this is because several of the feature selection approaches do not account for collinearity. Are you teaching us coding? Not really. This is how to write a research paper. I mean, it involves coding. Like, there's a bunch of Python files, but I'm not currently working on those because they're kind of done. So we're in the home stretch of this research paper. So not the most. I mean, it's LaTeX coding if you want to learn LaTeX. An ideal, like, so one approach to reduce. One approach to included variable bias. Is also a danger. Of included variable bias in the effects of interest is also a danger. Included variable bias is also an important concern to mitigate. To address included variable, to address these concerns, one approach is to take the candidate pool of important features and reduce them. He just wants some company. Yep, basically. To address these concerns, a linear and ordinary and OLS multiple regression that includes all 120 6 candidate features could be run. To address these concerns, backward feature elimination that optimizes on p-value. To address these concerns in an inferential study, backward feature elimination. Backward feature elimination. Does it have an S? Backward feature elimination. Optimizing on the p-value of each feature is okay. To address these concerns in an inferential study, backward feature elimination, optimizing on the p-value of each feature is useful. A high p-value, a p-value under when p is greater than 0.5, it becomes more likely that a coefficient is approximately, it becomes more likely that a coefficient is equal to 0 than that it is different from 0. When p is greater than 0.5, it becomes more likely that a coefficient is equal to 0. I can just say it becomes likely that a coefficient is equal to 0, and such variables should be eliminated to avoid included variable bias and overfit. What is this? Can someone explain? Hey, so I'm writing a research paper, and so it's open source. This is a LaTeX file, so I'm writing the actual content of the paper at this point. Previously, I was doing Python analysis. That's all done. The data, the Python code, it's all open source. And now I'm actually writing the paper. And so the topic of the paper is gender and coding bootcamps. Coding bootcamps and gender equity is the title. So the idea is, in the United States, we spend a shitload of money on higher education, and this creates a bunch of debt. And the debt is bad for everyone, but it's particularly bad for women. So women hold 60% of the debt, and they have, on average, reduced earnings capacity, which leads to reduced ability to pay the larger amount of debt that they already have. So it's a problem for everyone, but it's like a really big problem for women. And so coding bootcamps are a potential solution, because coding bootcamps are a great way to raise your earnings substantially, and also so you can use it in addition to college and probably raise your earnings, but you can use it in lieu of college and get a really high return on investment and cut your debt. And so the idea is, like, how can we incentivize women to use coding bootcamps, basically. Is it a bigger problem for women because a bigger proportion of men drop out of college? No, that's not a reason. That would be a reason that it's hard for men, right? Because the college dropout, regardless of gender, has a larger debt and a lower earnings. So if men drop out more, that would actually be harder on men, because they're going to have debt with reduced way to pay for it. Does that make sense? Thanks for the question, Satoshi, and I like the name. Go crypto. To address these concerns in an inferential study, backward feature elimination, optimizing on the p-value of each feature is useful. When p is greater than, it becomes likely that a coefficient is equal to 0 and such variables. Yeah, I can drop the and. Such variables should be eliminated to avoid included variable bias and overfitting. And overfit. A problem, the sample size of the current study constrains multiple regression of 126 features. The sample size of the current study constrains multiple regression of 126 features. As a second best approach, I reduce the variable pool using stepwise regression. I begin by BFE is applied to the for each elastic net, and then for the SFS selected variables, I apply BFE. How can I say this that makes any fucking sense? Oh, man. Ooh, makes sense. Thanks. Thank you, Satoshi. Making sense is the hardest, right? Do you disagree? Making sense is super hard. Using stepwise regression. For each, okay, so to do, maybe add a diagram here. I begin with the features identified by the elastic net without interactions. I apply BFE to the as described to I begin by applying BFE as described to those variables identified by the elastic net when considering the pool of variables without interacted gender. This leads to a, so how many variables are identified? This leads to a pool of how many? This leads to a reduction from 81. Do I ever mention 81? Okay, so how many survive, I guess is the question. So how many survive would be 2. Reduction step 2. Okay, so 67. Seven features survive this, survive the reduction. 67 features survive this step, this reduction step. I then add features that I then add features identified by the ElasticNet inclusive of interacted gender, I apply BFE again, and then I add SFS selected variables, then I apply BFE again. At the end, the original pool of 126 features is reduced to a pool of 76, right? Do I need to run this one more time? 76. K is 76. $76 features. All of these features each feature has a p-value less than each feature has p less than 0.5, and the model totally explains what is he doing? I want to get into coding. Yeah, there's a guy, Whittington. Can I comment on this bad boy? Y'all can see my screen. Line 439, Whittington. So check out that user. He writes in C and C++. Those are some of the languages you want to use for game dev. He does game dev and he also does cinematic stuff, like movie cinema and stuff. Video games are not so much my thing. Let's see if I can find Whittington on TikTok like this. No, it doesn't. He doesn't really pop up like that. I'll teach you to code JavaScript though, and React. That's what I recommend for web development. You can make games using React or JavaScript. It's just not like the main or normal way though. I begin by applying BFE as described to those variables identified by the elastic net when considering the pool of variables without. Each feature has p less than 0.5. The model fully explains the observed data and the each feature in this model has p less than 0.5. The model fully explains the observed data and the Akaki information criterion. Is substantially better than compared to a model built on the results of the elastic net alone. So where's the R squared? And with that, y'all, I'm going to kind of hang up for the day. Are there any additional questions? Nope, doesn't look like it for now. So I'm going to hang up for today, and I think that hopefully does it for this study. Thanks for joining. Bye, y'all.